Hi, Sheila. Are you there?
Yes.
Ah,
I'm here.
okay. I just wanted to test out my connection. Seems like it's working okay. You can see me as well?
Yes, I can see you. I'm just, okay. I'm also sharing. Hi.
Hi. All right, good.
Looks like I should change my camera. I have another one that I use. Oh, it's showing
Oh,
both
there's two of
cameras.
you.
Two of
Oh,
me.
nice.
Let me log back in.
Okay.
Okay, Rachel, do you want to test anything? Do you want to play with your presentation?
Yeah, sure. I guess it'd be nice if you gave me presenter rights, and then I could just see if I can control the slides and.
Was also going to bring bring load presentations as well, so that they are there. Just to give me a minute. And your name of your presentation name is what did you name your presentation?
It's named Traceability and Code Coverage. What we have in Linux.
Okay.
Yeah. I know Gab already uploaded them.
Oh yeah, they're there. I'm just uploading them to the BBB.
Okay.
So.
There they are.
Yeah, so let me see. So let me see. Oh, can I give you, I should be able to, when you see the bottom plus, can you make yourself a presenter? Or
I don't see it yet.
Okay. Should see take presenter. I don't know if I might have to ask if I have the right permissions here. I'm not seeing give option. Let me keep loading the other presentations. Should have loaded that. Let me bring more in.
Okay. Yeah, right now all I can do is set my status. If I hover
Right.
over my name, that's the only thing I could do.
Looks like David is responding. I should have the permission soon, and then I should be able to give you access.
Okay.
Hello, Shua.
Hi.
Hi. So let's how does it?
Gab. Hey, Gab.
Yeah. Hi. So have you uploaded the presentation decks already?
I am loading them, and then I'm also looking to see if I can give access to Rachel for her to test her presentation.
I see.
So yeah, look at the chat. I'm looking to get some access. Also, do you have access? Can you?
Yeah, I can.
You
make,
have access.
actually,
Go for it.
Yeah, I can see
Yeah,
that I can make Rachel a presenter. So
yes. Okay,
let's
cool.
see. Yeah, Rachel, I think you now are.
Yes, I see the
super
plus
user.
sign now.
Oh,
Woo!
good. Yeah, so it looks like you have access, Gab, and then I requested access as well, so that you're going to leave early. So
Yeah.
Okay, yeah, I can control my slides. All right, I mean, that's all I wanted to do.
okay, okay.
I'm good
Well,
now.
yeah, we needed to figure this out because Gab is going to leave like after the break or right around the break. So we both need access anyway. So we sorted that out. How do
Great.
you say your name?
Rachel.
Rachel. Okay. Just wanted to
Sorry,
make sure
not
I'm
sure.
pronouncing it
That's
correctly.
okay.
I should have known actually.
It's fine. Yeah, I know I've heard your name, Gab or Gabe. So I was always curious which one you went by, but I've been going by Gab. So
Yeah,
Gab,
me
yeah.
too. Okay.
yeah, you're a busy guy today with both conferences. Okay, well, I'm going to turn my video off and mute now, but thank you for allowing me to test everything.
Of course, if anybody else want to test, I'm going to start bringing. Okay, so now I don't seem to have access to manage presentations.
It looks like you're a moderator to me.
Yeah, I'm the moderator. Yes.
So yes, the presenter status is different and only one person can be presenter at a time. So as moderator, you can give and take the presenter status, but yes, you do have to take it back again in order to.
Okay, I did. Okay.
Which does, it's a bit painful sometimes in the referee track. You can't be doing other things and sort of making the slides downloadable because you have to take it away from the person who's presenting at the time.
Okay.
But yes,
I've
I
done
think
that.
Currently, yeah, thank you. Currently, I'm just bringing slides in so that we have them loaded up. Do I
Cool.
need to do loading one at a time, or can I
no,
load
you
them up?
you can load them all, and then the presenter can switch between them. When you load them, please could you set the downloadable flag?
Ooh,
So-
okay, thank you. I'll do that.
Thank you.
Okay, I will do that. I did that for that one. Gab, I have a lot of, I brought in a lot of presentations. I mean, I will upload all of them to BBB, then we can switch between them.
Okay, that's great. So, and I think, I mean, when I left the symposium, I think Lucas has still had to upload the deck. I'm not sure if maybe.
Oh, okay.
Let's check.
Hi, Steve. I saw you join. Do you have any tips for me?
Well, Dave probably mentioned a lot. I'll probably hang out this one because you have some of the interesting topics I want to probably participate in. But yeah, a lot of things. I'm going from microconference to microconference, giving the same spiel of what David was kind of saying. Was one, make sure all your slides are uploaded. Two, I actually was mentioning the other way. I've done this where someone gave me their slides during a presentation, someone else's presentation. So what I did was I knew the person was going to be on the slide. He just switched, and I knew he was going to be on that slide for some time. So I stole the presentation from them, uploaded the slides, and then gave it back to them without the presenter even knowing that I did it.
Oh,
Unless he might, I don't think the person was just talking. I just switched it out, switch it back, and so that is possible. You can play with it. Yeah, you can upload multiple at the same time. That's what I did. Make sure they're all downloadable. What I also tell people, since you can't look at the shared notes and the chat at the same time, and it's very disruptive to go from one to the other. Actually, you don't have it in here. Let me put in the link. This is the Kernel Dependability and Assurance, correct? Just want to make sure.
correct.
So I'm going to, this is what I've been recommending to everyone. I'm putting in the shared notes right now. That's the link to the chat. So what I do is I tell people to open up another window, only for those that want to participate or in taking notes. For those that want to participate in taking notes, they should keep the shared notes up, open up another browser window, go to that, put that link in there, and that's the chat. That will be the same chat that you'll see. That's if you click on the chat. This way you don't have to switch back, because by switching back and forth, it takes like 8 seconds to do the switch, and 8 seconds is an eternity in a presentation.
Right.
So that's why I tell people, if you're going to take notes, only those that are taking notes. If you don't care about the notes, stay on the chat. It's fine to have the chat right there. But if you want to participate in the chat, just switch over to the link up above. Much more. That's what I did yesterday, and it worked really well.
Right. Okay.
Any other issues you may have, or questions or comments?
Gab, do you have any questions? You're going first, I think, with your presentation. I'm bringing all of
Yes.
those in.
Just a question. I mean, I was just looking at the shared notes link. It asks for username and password. Is it the same as the,
It's the same username and password that you would have coming into the conference. The only difference is the email, that it's your email, but the @ sign is a period, not an @ sign.
Okay.
That's because Matrix doesn't allow @ signs in usernames.
Okay. Okay. Thanks.
Oh, good
Yeah,
to know. I
Yeah,
have been
I will,
using
yeah.
@ all of yesterday.
Well, did you get into the Matrix chat? It won't let you in.
Oh,
If you,
I'm in there. Oh, okay. Okay. You mean not when you are flagging somebody, you're more like when you are entering. Okay. Yes, I'm
yes.
good, I think. Yeah. Okay.
Yeah. Maybe I should put a little note in there. Username is your email with @ .
So did Lucas upload his
Yeah, he did. He did. I just checked,
Okay.
and it's there.
okay.
I'm not sure.
I downloaded everything, and I'm making sure I have all of the presentations here. Okay. I'll bring the next one in.
I'm trying to log. I mean, I'm not able to log. So you said the username is my email.
Yeah,
And you
used to-
have the
should be the same email that you used to log into Plumbers.
and then the
And-
confirmation number, right? That confirmation number you
I
get.
think the confirmation number is the same password. So it's same
Mhm.
username, same password. The only thing is your username is I should put.
Right. Yeah, it worked. Yeah.
I uploaded 3 presentations, and then I'll keep going.
I'll probably be hanging out here. Although we also have Kate that's here. So we have 2.
Oh, okay.
community members.
Kate is here. Hi, Kate.
Hey, yeah. Yes, I'm here.
I'll be hanging out too.
Okay, cool. Do you know if the real-time one has been streamed? Is up now?
Yeah, it
Okay.
was up yesterday.
Okay, great. Good.
Yep, I actually went back and watched some of it. So
Yeah, I want to myself. Thanks.
Okay. I should have applied. Now we should have everything, all of them. If anybody wants to play with the presentations, they're all in there now.
Testing, testing. I'm just checking that you can hear and see me for the.
Yes, go ahead. Yeah.
Yeah, I'm running the fourth presentation or session, I should say, because it's a mini conference.
David,
Just,
can you try to sound though? Your gain seems a little like maybe too loud. So a little
okay.
bit. Just a little bit.
Let's see if I can adjust that.
That sounds better.
It's just because I think I moved. How's this?
Oh. Okay. It's good.
Testing, testing. I'm still talking, and
No, I think you were talking louder before. That's why it seems like it had a staticky sound to it. So now your voice is a little bit lower. So sounds good.
Very good. Okay, thanks. I'll you have my presentation, right? Or slides at any rate. Shua, am I pronouncing your name correctly?
Correct. Yes.
Yeah. Okay. Great. Thanks. And do you have my slides? I uploaded them last night to the.
I uploaded them to BBB.
Okay.
So
Great.
let me see. Can you? You can. Let me give you. Yeah, they're all in there. Your presentation. You call that
The
FAnalyzer.
GCC
Yes,
dash FAnalyzer option. Yeah.
Yes, I have
sure.
PDF loaded up there
Wonderful.
with the downloadable option.
Do it just to let you know, as you're running this micro conference, usually I found it's better that you will change the presentation for the presenters so they don't have to go find it. So just change it first, then give them presentation.
Okay. And we should see your presentation here, David, now.
Yes. Great. Thank you. Presumably you'll give me presenter rights when the time comes.
Yes, you'll be getting presenter rights.
Right.
Thank you. All right. I'll go back to lurker mode then. Thanks.
So looks like Steve, I don't have the moderator rights. Gab has. We probably need, both of us need. Gab is going to leave in the middle.
Okay, let me find you.
Okay, thank you. So I can't make anybody presenter at the moment.
You're a moderator.
Yes, I am.
Well, maybe someone else beat me to it or something. Or, wait,
I
you have
don't know. Yeah.
You should have moderator rights.
Okay. So
if you do like left click, you should be able to say on the person's name on the left. It should give you
The ability to make them a presenter. Yeah, both you and Gab have moderator rights, and right now you're the presenter, Shua.
oh, okay. So let me see if I can.
run a grab a cup of coffee real quick.
That sounds like an awesome idea.
Okay, David, you should be present. I gave you the presenter rights right now.
Okay. Okay, great. So, so it's 5. It's okay. So now it's about time. Should we get started?
Yeah.
Okay.
You wanna go ahead, start the call. Okay. You're the presenter now. Let's switch. I'll switch the. Okay. So that's what Steve was saying, that I should first load the manage presentations first and then.
Hey, Shua, if you could just load the default, thank the sponsors, and then
Yes.
that would be really helpful for us. And then load up and then, whatever, if you've got a slide or two to welcome everyone for this mini conf, that's talk to that. Otherwise, go into the first presentation. How about that? Great. Thank you.
So welcome everybody to the Kernel Dependability microconference today. And we have several people to thank for sponsors, Facebook and IBM Microsoft ARM Gold sponsors, and silver sponsors AWS, Netflix, and Red Hat. And the speaker gift sponsor is Collabra. And with that, we have a t-shirt sponsor, VMware. And then, of course, the Linux Foundation for providing the conference services and so on. And with that, we have an anti-harassment policy. Please abide by that when you are speaking respectfully and talking and then participating in discussions. Check your microphone, camera when not actively participating. And we have a chat and we have shared notes. Participate in the chat, ask questions. And the presentation format is 15 to 20 minutes of introduction to and then discussion on the topic. And thank you, the planning committee, for doing, putting in all the hard work, making this possible. And let's see, I'm going to switch to the first presentation. That is Gab. You are going first, right? With your presentation.
Yes, it's myself and Daniel.
Okay. And I think I loaded that presentation. Let me see if I can bring that presentation in. So I am going to make you presenter. I'll give you the you can take the presenter back, Gab, and I don't know if I have the right presentation for you, but you can load that.
Okay, great. So thank you very much, Shua. So let's see. Yeah, this is the right one. Okay, so yeah, thank you everybody for joining the macro conference. Myself, I'm Gabriele Paoloni, working at Red Hat as an open source technical leader, and I'm also working, you know, in the ELISA project, and I'm leading the architectural working group, and also chairman of the governing board. So today we will talk about, we want to talk about an idea, okay, that Daniel and myself had like some time ago. And so before we jump into the topic, maybe Daniel, you want to quickly introduce yourself.
So hi, I'm Daniel. I also work for Red Hat. I work in the real-time team, mostly working on upstream stuff, and generally related to verification and real-time and scheduling. Yeah, that's me. I'm not a leader on anything, just on code.
Okay, good. So let's start then. Okay, so this is a redundant slide as we already talked about ourselves. And right, so today we first, you know, quickly summarize what is acid decomposition, and after doing that, we want to see if it is applicable to Linux driver subsystems, when it is worth applying it, and then the core of the discussion is how. Okay, so how can we do that, and there will be any penalty, so stay tuned. So let's start. Okay, so acid decomposition is a pretty straightforward methodology that is described in the ISO 26262. And what it says is that if you have a top-level requirement that is assigned with an automotive safety integrity level, like ASIL B, for example, you are able to decompose this requirement into redundant independent requirements of different safety integrity level. And you can basically and you can compose, these redundant requirement in a way that the initial top level requirement is met. Okay. Now, this description is not probably very clear, but let's make an example. Okay, very quick one. Okay, so we have a car display. Okay, and the car display says, okay, so the use case is following a car failure, the display system shall project the respective correct telltale within 100 milliseconds. Okay, and this is ASIL B. Okay, so there is a car failure, a telltale must be projected, and this must happen within 100 milliseconds. Okay, this is the top level requirement. Okay, now an example of decomposition is we can say, okay, you know what, qualifying the main system with an ASIL B, it is, for ASIL B, it can be too expensive. Okay, so what we do is we develop, the display system with a QM of B, safety integrity level, and aside, we put a safety monitor, okay, and the safety monitor is checking that every time there is a telltale request, the telltale is displayed within the maximum time, 100 milliseconds, and it also checks the telltale to be correct. So effectively, we decomposed, you can see that we decomposed the initial top level requirement into two different requirements. The first one is the same. However, we downgraded the ASIL from ASIL B to QM of B. And then we added an external monitor that now it is, assigned with ASIL B of B. Okay, so the sum between QM and ASIL B of B is ASIL B. And so this is the way we satisfy the initial top level requirement. Okay. When it is worth doing this, it is worth doing this when the cost to develop and qualify the external safety monitor, in this case, is significantly lower than the cost of qualifying the main display system, for example. Okay. Okay. So now, if we apply this concept to Linux, so this is a typical way of achieving this decomposition on a Linux-based, for a Linux-based system. Okay. In this example, you can see that we have the Linux kernel that is QM of B, and we have a QM of B application running on top. Then we have underneath an ASIL B hypervisor and an ASIL B hardware. Aside, we have an ASIL B safe OS and an ASIL B of B application. Okay. Indeed, the QM of B element and the ASIL B of B elements, these are independent. Okay. The hypervisor is, guaranteeing that they do not interfere. And this is a pretty straightforward way of achieving decomposition in Linux. Now, the problem with this approach is that it is expensive, right? So the bill of material is significant. We need, like a hypervisor. We did, here we have two operating systems, and then we have two diverse and independent applications here. Okay, so it's my question here. What is the cost behind this, right? And this is the idea. Okay, so the idea here is, so the question is, can we decompose? Can we apply decomposition within the kernel itself? Okay, so, and what does it mean in practice? Okay, so in practice, it means that for a specific use case, okay, we identify the subsystems that are functionally required to support this use case, and we get this subsystem monitored, okay, so that if there is any failure in the monitored subsystem, the monitor itself will raise an exception. Okay. Now, there are behind this concept, there are a lot of challenges, right? So first of all, the monitor and the monitored element, they must be diverse and independent. Okay, so and one way to achieve this, for example, how do we design the monitor, right? So also yesterday in the referee track of LPC, so we introduced with Daniel the runtime verification monitors. Okay, so this is a way to design a monitor of a specific subsystem for a specific functionality. Okay, and but then, okay, so even if we achieve the design of this monitor, we can see that the monitor and the monitored element, they are both running in the kernel, in the same address space. So how do we make sure that these two elements are independent? Okay, so how, how can I make sure that a failure in the kernel do not affect both elements, in a dangerous way? Okay, so and effectively, so I mean, do we have some mechanisms to design the monitors, especially the monitors, in a way that they are less subject to possible interferences, right? So, and these are the key question for this discussion. Now,
is that a question, or is that the question you're asking? Yeah, why my camera's like all unfocused? But so your question is, can we separate address space from like? So like what I'm saying is you have the monitor and the element running in the same address space, which means that if something goes wrong with the element, it could actually write over the monitor and kill the monitor as well. I guess that's the problem you're having. Is that correct?
Yes, for example, and the idea maybe it's not so. Okay, so now you said like, okay, can we separate the address spaces, right? So, but another we are trying to figure out if there is any possible mitigations. Like, for example, something that we thought with Daniel was, okay, maybe we can, so the monitor itself has got like a sort of matrix of states that must be monitored. Okay, so maybe one way could be, okay, so the matrix of the states, that can be made read only, for example, right? So
well, it's not just address space you have an issue with. You also have exceptions. So basically, if the kernel crashes, won't it crash the monitor? Or I mean the element and the monitor. So if the element triggers a triple fault, it's going to take down the whole virtual machine.
That's a good one. So exactly.
But crashing the system is not that bad if crashing is an action that we would like to have if the things go wrong.
So basically, so if that's what you want, I mean, it depends. I don't know what the requirements are here. So, I mean, you could have the monitor say, like, you could have an external monitor saying the system just crashed. So basically, if it triple faults and kills everything, it will kill the kernel. That will actually trigger, at least the hypervisor will detect that it was the triple fault. And then that can be passed in. So you could, so I'm assuming because Linux is actually running as a guest on a special hypervisor that's has its own monitoring. You just have to make sure that the monitor still runs if the element dies, but if the kernel dies, it's fine. So either you protect the monitor by page table protection so that it can't write to it. Like you said, set everything to read only. inside the monitor. So any reads or writes will not affect it, and hopefully it won't affect the tasks. I mean,
Yeah, just to explain the monitor, what we have is the code itself of the monitor, one matrix of states, and one variable per element that we are monitoring. And this variable per element is read-write. All the rest is read-only.
you could set, no, but the thing is, you could set it, if you want to play with games here, have that task, have that variable not actually read and writable from the kernel itself. You'd have to play with the memory management a little bit, but this is feasible. This is in theory possible. Is you have maybe a kernel thread that has its own page table. To read and write to this, it would take that and it will just get its own page table and then have access to it where none of the else of the kernel has any access to it.
Question, and then that you are the right person. What if this the monitor is actually running hooked to an event that has interrupt disabled, like the SCAD switch? Can we do that? Because the monitor, it runs hooking by the events, for example.
Yeah.
And event, one example, let's get one, it's like SCAD switch. If I want to create a monitor that monitors all the SCAD switches, we have some restrictions for running there, right? We are with the interrupts and preemption disabled. And one of the features or one of the things that we're exploring with this kind of monitor is that it is synchronous to the execution. The monitor, it will only return to the execution after processing the event or taking an action, for example, and then returning and then continuing the execution. Right. So we have some restrictions of the things we can do.
You could also have the monitor, have it be, this might be a trick, I don't know if this would work for you, but have it read only for everyone, including the monitor, even the variables. When you write to the variable, it takes a exception and have the update done in the exception handler if it happened by the monitor.
Okay, that could be a thing.
Yeah.
That could be a thing.
How often do you update the state? I mean, is it every time you update the state? But you could take a exception handler on that.
Yeah, the update it will depend on the thing that we will monitor, right? It depends on the frequency of the events. It could be as high as all the preempt enable and disable, for example, which is very frequently, or it can be less frequent, like SCAD suites. It depends on the thing that we will monitor. So maybe for some monitors, we will not require such level of insurance. But yes, like for the watchdog monitor, we might require. How frequent do we will have events on the watchdog monitor, Gabriele? You that know more than me.
Well, the watchdog, it depends. I mean, what we want to monitor, right? So here, I mean, for the watchdog, it's very critical to monitor that the timeout it is set properly. Okay. So once the timeout is set, then the watchdog the safety watchdog will start. So if by any chance we miss to pet the watchdog, then the safe state will trigger, but that's fine. I mean, the customer would be very pissed off if there was no hazard, but
I mean, not how frequent the watchdog would happen, but how frequent the events that we are monitoring happen.
Actually the question is how frequent is the update to the variables? Unless it's every time an event happens, do you update the variables?
From the monitor side, likely, unless you are just spinning on an event that doesn't move from state. But generally, it will change on every state change. It will write to that variable.
Yeah, but this is a very good idea because anyway, the exception handler, we need to qualify it according to ASIL-B somehow. So basically, we need to trust the kernel mechanism to handle exception. Okay, so and effectively, if you're able to update the variable using the exception handler itself, it would sort of come for free, effectively, right? So nice dog.
Cat.
Oh, cat. Sorry, I couldn't see it properly. So yeah, yeah.
Yeah,
Uh,
one good thing about the monitor is that I didn't try to run all these software, the static code analysis, and try to see if these uh, if the code is compatible with all the rules, like the code, the data only goes, no, the code only goes forward. The memory is always statically allocated. I'm designing it for it. I don't have a dynamic allocation while the monitor is running. The code only goes forward. So we will likely have a good life with all these other things we need to check. And it would be good to have a list of things that I would have to do to have the monitors in the way that guarantees like the the quality of the code. But the challenge seems to be more on these on writing these state variables.
Being attacked. She's like, pay attention to me. No, I mean, actually, well, the fault handlers are rather simple. I mean, they have to be. So to verify the fault handling, I mean, but then again, you take a page fault, then you have to verify the hardware. I don't know how much you need in the hardware verification to make sure everything's fine there. Plus that's and updating on page fault. I don't know, like I said, performance-wise, you need a stack. You know, it will save the stack. Everything else. Another. I don't know if there's any other way to save something in a special register or not, but then again, registers could always be trampled over, so it's hard to maintain state. That's not. So basically, the monitor is just event-driven. It's not. It's the monitor. I'm assuming is not a thread or not a process. It's just a. It's just something that's attached to the event. So when events happens, it triggers the monitor, and then it works there.
Yeah.
So to change, so that means there's no one context that you can have. And the other thing is if the element is a thread or whatnot, you could at least keep the element itself from touching the monitors. That's another option. So when you schedule in the element process, if it's a process or whatever it is, its context, you could keep it from touching anything.
One thing that we need to be careful here is, so you say, Daniel, so the monitor is event driven, right? So now we talked about the spatial interference. So we just said, okay, now we talked about, okay, you know, this way we can protect the address space, you know, of the monitor. How to make sure that the monitor is alive? So how to protect the monitor against time interference? Okay, so and this is, I think this is something that we need to think about, because correct me if I'm wrong, but if the monitor is event driven, so it's not a thread, the monitor itself is not able to pet, you know, an external watchdog regularly to say, hey, I'm alive, I'm alive, I'm alive, I'm alive, right?
You might need something to excite the monitor.
Ah, yeah. Okay, so basically you can have a thread to trigger the monitor to make
A
sure
thread that generates an event, and this could be like even let's say a thread that pings the watchdog. If it generates an event in the monitor, we could send an event. We could have a reaction specific for an event. This event always hit a reaction, and this reaction is always pinging the watchdog. That's something it's easy to.
Yeah. So
you seem to have two issues, right? One is is the monitor running, testing the status of the monitor, some kind of keep alive. And then also, how do you isolate the monitor from your watchdog itself. There is an isolation problem that you're looking at, and then also how passive or active the monitor should be in terms of interfering with the rest of the system. And the third issue is, do you know if the monitor is even running? Is that kind of summarizes at a higher level?
Yeah, so the monitor itself, we kind of trust it in terms of, so we are not worried about possible interference from the monitor toward the rest of the kernel, because the monitor itself is qualified according to ASIL B. So there will be a sort of, you know, it should be developed according to, just the monitor should be developed according to the ISO 26262 requirements. So you have a high degree of confidence that he is a good guy. Let's put it.
Right, that I get, but I mean from the safety perspective, but I mean the interference on the system. How passive is the monitor itself? Meaning when it's updating variables, or how much of the system is it impacting? Whether it's safe or unsafe, that's slightly different aspect, right?
The monitor is pretty much isolated. It doesn't depend on anything. It's self-contained code. So and it doesn't run like with a thread or anything. It runs in the same context of the current context. If it's an event that's happening inside an RAQ, it runs inside the RAQ as code of the RAQ. If it's in a thread, it runs synchronously with the thread as if it was the thread code. And it's self-contained. It might leave its self-code calling a function outside of its context if there is a reaction that it would cause. For example, if I am receiving only events that I recognize, it might just stay on its own context. Reading values from that matrix, writing on that variable that we mentioned, and running on its own code. And currently, the zone code is all inside the same function. When I have a reaction, I might call code external of from the monitor. And then an exception could be call panic. An exception could be write to the trace buffer. But it's all under control.
Yeah. So the only possible issue that I can see is that if we have, let's say, we have a top level safety application here, right? So now the timeout set is not a proper example, okay? But let's imagine that we have a sort of, I don't know, autonomous driving application, so something more complex, okay? That comes with also with critical timing requirements, okay? So the only issue that, you know, I could be worried about is, now, if we have the monitors alive running in the kernel, are we still able, you know, to meet the FTTI deadlines, right? So the safety critical deadlines for the safety function itself running on top, right? Yeah. So this is maybe, you know, one aspect.
You're concerning. You mean? Let's see if I get. You're concerning about the overhead that the monitor would imply in the application, right?
Yes.
Yeah, it depends on the. It will depend mostly on the granularity of the events that we want to monitor, right? I can run this monitor with events like that run very frequently, like a preemption disable and enable inside the kernel, trying to force it. It doesn't. It runs and the system goes slower, but it's unlikely to think that we will monitor at such a granularity. So the fact that system stays stable, even monitoring on tests very high frequency events, it's a good sign. But yes, we will need to take care of the granularity that we aim at monitoring, right?
And it should be measurable. I'm assuming that the monitor is 01. It doesn't have a variable. So all time the monitor has a max time that it will take to every event it goes off. You have a constant time, constant max. So, and since it's triggered by events, you can look at the events that are caused or in the path of the element and trigger, say, okay, in this time frame, we have X number of events. Take the X number, times it by the time, and then look at the rest of it. Is this going to affect our deadline?
Yeah, yeah. Just to have an idea of granularity of the overhead of the monitor. In the experiments I did in the past, it was faster to run the monitor than writing the information it was tracing to the trace buffer. So that's information that Steven can have a nice idea of granularity. We just need to figure out how much overhead we will have with this idea of changing the state on inside a trap.
Yeah, that might be an issue. That's the only thing I worried about, because that causes synchronization issues. So it does a lot of things in the hardware that will slow things down.
Yeah. Still, we have a good starting point. The starting point is promising.
And that's why I said maybe if it's possible to keep the element or whatever you want from writing to it, or do you have to worry about the rest of the kernel modifying or rest of the kernel corrupting the monitor? Is that the issue you also have to protect? In other words, do you have to make sure that this variable in the monitor cannot be corrupted by anything else going on in the kernel outside the element?
Yeah.
Yes, this is why we say try to update the variables using the exception handler, right?
Yeah.
Okay. So I think this is, I mean, this was a very good feedback, and I mean, it gave us, quite very good, very good ideas. Now, I think now the key question now is it worth doing it? So if you remember the initial slide that I presented about the decomposition, right? So we said, okay, so we have, what is it? Let's see if I can bring it back. This one. So here we have, on the top, we have like a pretty complex system, right? With this complex MCU, complex operating system, doing the displaying of telltale. And the reason why here it is worth to decompose, it's because here the monitor is much simpler. Okay, so here what the monitor does, it basically treats back the display buffer. It calculates a CRC, and it compare the CRC against a predefined lookup table according to telltale that is requested, right? So it's really a pretty simple design. And now, when it comes to, let's going back to the context of Linux monitors, right? So here we already discussed about isolation. Okay, so here we are, we are building a confidence that these monitors can be pretty much isolated. Now the key question is, what is the effort of qualifying the monitors, of developing the monitors in this case, because they're not there yet, compared to the effort of qualifying Linux for a specific functionality. And my personal opinion is that the challenge with qualifying Linux for a specific functionality is that we have active kernel code that is usually not only that is not only reacting to that functionality, really. So, but what's happening is that we are having, interaction with all the other subsystems. VFS Watchdog, we can interact with all the other subsystems according to different many stimuluses, right? So instead, if you look at these monitors, this can be, only designed, to make sure that when there is a certain stimulus, the reaction is the expected one. So in my view, I mean, I have the feeling that yes, it is worth, because it, at the end, the model of the monitor only focuses on a specific functionality, and the level of complexity is only bound, by the functionality that you're looking at, right? So, this is my line of thinking, to be honest. Now, I don't know what is your view, about this point.
Let's exercise one thing. The good thing about having the monitors in software and part of Linux is that it's reusable for all the people that would like to use Linux on safety critical systems. Different of an external monitor that might be used by one vendor, by another vendor, by another vendor. And the feedback that the software monitor gives to the Linux. Okay, there is this case here that's actually monitoring an active system, right? But there is also another aspect, which is using this for testing, right? Having it in software inside Linux gives more evidences for testing Linux. As one point, right? Other points, please, audience.
I haven't been in the field long enough for playing with the automotive side of things and understanding exactly what's going on.
So I agree that if it's part of the Linux, then it would be easier for monitoring. I mean, external, keeping the monitors, we have to keep changing the monitors. Of course, they have to evolve, right? So it would be good to be part of that. However, I do think that isolation and overhead need to be really controlled, depending on, you're mentioning, Gavin, that how responsive, how much, all of those things, that would be the real critical issue. Or how do you isolate it from the rest of the system? And how would you keep the overhead low enough that it is not impacting the critical aspects of any safety critical system? So example, I keep saying this example, that if you have if the monitor infotainment versus actual critical operation, so it has to go forward, right? That's where the isolation comes in. When a monitor goes down, obviously you don't want to take the critical systems down. So you have to keep that isolation and overhead down. That's kind of my thinking.
Another thing that hasn't been brought up, by the way, I also have you thought this could also be used possibly for security systems? I mean, for security, instead of just for monitoring that the hardware or something's working, but actually monitoring that the operating system is doing what you expect it to be doing. And if you have a bunch of states that you could define, when my system allows these states normal, if something happened where someone tried doing an attack on the system, it changes the states. Could that possibly cause an issue of some kind, so that it could be detected through a monitor? I mean, it's not just safety critical.
Yeah, the monitor has many benefits and users, right? The things that are there now in the first RFC of the RV, the code is self-contained already. It is O of 1 for each event, and it seems to be faster than tracing, which would be the evidence that could use for understanding the system, right? So the starting point seems to be good and useful for a vast majority of cases, that not the ASIOB that we need to understand. One question is, how many monitors do we think we need on a system?
That is dependent on the use case. So, I mean, I don't know, because I mean, if I think about now the telltale use case that we are working on in ELISA, right? So there are two main functionality that are really safety critical. So the first one is setting the watchdog timeout that we just mentioned. The second one is making sure that the safety application itself is able to take the right decision. So the safety application is reading a message coming from an external hardware, is unpacking the message, checking if the message was not corrupted, and is also reading the message, say, okay, everything is fine. So I pet the watchdog. So now this means we need to, guarantee the integrity of the process address space. We need, if there is memory map involved. Now I cannot remember, but basically we need to guarantee that, that basically we don't have interferences between processes, so that the memory subsystem work okay. So another question is, okay, then how do we qualify the memory subsystem, for example? So do we need, to put monitors there as well? So this is something that we really need to look into, and I don't have an answer right now. No.
Yeah, but wrapping up, I think from my side, I have an idea of where to go. So I'm trying to make monitors safer for the application, and that's part of the code that I'm sending actually to be part of the tracing subsystem. So Steven is aware. So from the coding side, I think the people involved have an idea of where to go. That's a good good outcome of this discussion. Really.
Any last minute comment, question? Don't be shy. Okay, 1 minute. Okay, so tell you what. So the next step in my view is let's try to to design a watchdog monitor and try to push it upstream, and let's see what the feedbacks are. Okay,
Design the monitor. Yeah, it will be design the monitor. Try it as is with the monitoring now. I will soon send the version 2 of the RV interface. And then with that, with the version 2, I can ping Steven and get some ideas on the trapping part of the code and how we can change that. And Steven will be warm in the code as well, because he will have to review it. Anyway, good. We know where to go. And then obviously doing benchmark and collecting more data.
Okay, so thank you very much, everybody. Time is up, and it's time for the next session. That is Rachel, right? Is it correct?
Yes.
Yes. Yeah, let's. So Rachel, I'm gonna make you presenter. So please select the. I'm gonna hide myself, and yeah, please select the right. Great. Okay.
All right. Thank you. Okay. So a little bit about me. My name is Rachel Sibley. I'm a quality engineer working at Red Hat. I've been with the company for about 7 years. Actually, next Wednesday is my anniversary. I'm currently working as the QE technical lead for the new automotive initiative at Red Hat. Previously, I worked in Kernel QE team, embedded in CKI as the test lead with a focus on coordinating test coverage for the kernel. So here's the agenda of what I wanted to cover. It's the main focus that I really wanted to touch on today was the importance of traceability and code coverage techniques, which is important to functional safety systems. which in turn is important to the automotive industry, of course. So just to give some background, we can talk a little bit about what the automotive initiative is and CKI and Kernel CI and how we'd like to leverage what features they have in place. So for the automotive industry, the automotive initiative here at Red Hat, this is a new initiative that Red Hat is embarking on. They want to join the automotive space, and they would like to deliver the first certified Linux operating system for road vehicles. So it's going to be heavily based on RHEL. So we're going to want to reuse and leverage RHEL's existing testing development practices for automotive. And there's going to be new areas to explore, like infotainment and functional safety. Functional safety is going to be one of those big areas, of course. Requirements are going to be closely tied to the certification process as they're identified. So this is going to happen during brainstorming sessions that we've already been starting up as we identify potential hazards and review our existing processes for gaps. So I just mentioned we'll be reusing the development and testing practices we have for RHEL. This includes the use of CKI's features, including both code coverage analysis and targeted testing. So for those who aren't familiar, CKI is Red Hat's public-facing CI service, responsible for testing and gating downstream kernels, in addition to providing testing and feedback for the upstream kernel trees. CKI is part of the Kernel CI upstream project and a member of the Linux Foundation, along with other public-facing CI systems where they're working together to aggregate the reporting using KCI-DB, Kernel CI database. There was a talk given by Nikolai Kondrashov, I believe it was yesterday. So if you're unable to attend, definitely check out the recording later for details if you'd like to find out more. So the ISO 26262 specification, it's a standard for functional safety and road vehicles. And it includes a statement on the importance of code coverage and traceability to software requirements. Code coverage becomes increasingly important according to the ASIL level. The ASIL level refers to the automotive safety level, the automotive safety integrity level, and that can be used to classify risks. So by using code coverage, it enables us to provide the evidence and traceability that our testing is either sufficient or we have gaps in our testing which need to be corrected. So what we have today is still being worked on, but right now with CKI, it fetches a pre-built GCOV kernel for RHEL versus building the GCOV kernel directly in the pipeline. You can trigger code coverage analysis by calling a bot on a related merge request for onboarding a new test. Also, Red Hat's kernel development recently moved to GitLab, so where the patches are submitted and tested, and then feedback is linked directly back to the merge request level. So here is another place we can also trigger code coverage analysis by modifying a config file. So there's work ongoing to enable code coverage analysis in the RHEL pipeline where the GCOV kernels are built in CI. And eventually this could be extended to also support upstream kernels. Currently it's disabled temporarily while the team works on porting it to work with the new provisioner, UPT. But work has already taken place to open source the wrapper tests which use LCOV. LCOV is a graphical front end to GCOV, which is used to generate the HTML reports. Code coverage can also be useful to identify gaps at the subsystem level. For example, we can filter down using the kdir parameter to provide a more granulated report by focusing on a specific directory or a list of directories in the kernel source, and then run tests that relate to that subsystem. We also have the option to combine multiple reports and tests into a combined HTML report, which is nice to have if the test runs are triggered at different times or they're run on different hosts. Both merging and report generation are now handled directly in the pipeline. So here's an example. Hopefully you can see it. This is being run on XFS tests, and here we're narrowing down on the FS/XFS directory in the kernel source using the kdir parameter. By default, it automatically pulls in related libraries, but you can see here in the report, it actually doesn't look so bad from the coverage perspective. 74% seems pretty good. Of course, you'll see a big difference in coverage if we were to run this against the entire kernel. So it's nice to be able to drill down when needed. So another method for measuring code coverage, traceability, and linking them back to test requirements and features. This is something called targeted tested that CKI has. So to provide an overview, it's a tool called KPET, Kernel Patch Evaluated Testing, and it can be used to evaluate each patch under test and automatically run matching tests which relate to the changes introduced in the patch. It uses regex patterns which relate to each test found in the KPET database, and then it will trigger automatically as patches are tested in CI. And this is based on changed file or directory names. So it can also be used for running a subset of tests which relate to an upstream kernel subsystem. Since right now we're not testing upstream kernel patches yet because of security concerns, but it's being worked on. So for example, you can run all the networking tests for the netnext tree. As an example, the tests are categorized by different types that relate to a subsystem level. KPET is a framework in the CLI, and whereas KPET DB is the database which defines the condition for each test case. So you can take a look at the bottom. There are some examples of how to preview related tests for a specific patch, or how you would invoke the CLI to generate the XML, which is the input that we use for the restraint harness, which is used with the UPT provisioner. So possible improvements. I mentioned earlier about the targeted tests, and right now it's purely informational. CKI has a nice dashboard called Data Warehouse where you can take a look at every single result and then see whether or not targeted tests were run on the kernel builds or patches. And it's informational now, but what they'd like to do is actually gate on merge requests going forward, where if a meaningful test isn't run on a specific change, then that change is going to be blocked from being merged until a test is onboarded that would actually run and target what's under test. So that is a feature that I know CKI is looking into, and they're targeting maybe spring of next year. And then the other part would be about actually having code coverage analysis run automatically in the pipeline, which is, as I mentioned, that part is almost done, at least for RHEL kernels. There's some finishing touches about they were dealing with artifact size limitations, but I think that's mostly covered, and still working on some other parts to get that completed. But having that run automatically at a regular cadence where the reports are stored somewhere where you can review them and determine where the gaps are. So I have some questions that I wrote down, but of course I'm open to any questions besides what's listed on the slide. But some of the questions I have so far is I'm interested to hear if anyone else in the room has actually used code coverage analysis and do you find it useful? Is 90% coverage, is that realistic? Have you seen numbers that high, especially for testing code coverage on the entire kernel, or it's more of at a granulated level where you're specifically drilling down on a subsystem level? How often are you actually running it and generating the reports? Are you doing it at a patch level? Are you doing it testing baselines periodically? How are you actually doing it? I know building GCUP kernels can be not only time consuming, but expensive. If you're not running it for every patch, then how do you know that coverage is good enough? What other techniques are you using for code coverage besides something like targeted testing or code coverage analysis? Code coverage is, as a verification measure, it's expected to track the software requirements all the way down to the design. So what else are we missing in Linux? So yeah, open to hearing suggestions or hearing what people are currently using now for code coverage and traceability.
There are a couple of comments in the chat, Rachel. Sorry, Brennan, go ahead.
Oh, no worries. We can go over the chat questions first.
Yeah, so I'm just taking a look. Syscaller uses kcov. Okay. Yeah, can you talk about that a little bit more? How are you using it? Is it something that's run on a regular basis? Is it useful to you? Okay, so I see there's a link to the code coverage reports. I can take a look at those. Thank you for sharing those. Okay, coverage reports are very useful for assessing how good the testing is, what's missing. Basically, the only way to ensure that what the developer thinks is covered is really covered. Agreed. Okay, I really like the idea of gating patches with missing targeted tests. Currently, we are doing this manually. Are you planning to automate this? Yes, so right now it's automated in a way where we're showing whether or not patches are including targeted tests or meaningful tests that are run. That's what KPET's used for. So right now it's informational, but CKI wants to actually have it where it's run automatically in the pipeline, where it will block any merge requests from being merged. So that's that, not only with tests failing, but in addition, if there's no targeted test or meaningful test running on that change, then that change it's going to be blocked. So I know that's a planned feature for CKI. Yeah, and Veronica already answered that. Thank you. Okay, important stuff. Also interested in getting a sense of what code is covered by customer workloads. GCUP has performance impacts that make it inappropriate for customer deployed kernels. Yeah, one of the things that I noticed with code coverage when we were playing around with it when I was on the CKI team, when you're running it with a large number of tests, kernel tests are inherently known as to be flaky. So if one test in the middle of that run fails or causes the system to crash, or maybe it finds a real bug, the rest of the tests don't get run because the system resets or there's a timeout, a watchdog timeout or whatnot. So sometimes it can be difficult when you're trying to generate the reports and get the feedback there if one test misbehaves. So I know that's one of the issues that we had run into. Lots of the code in the ARM64, that's part of what most I'm familiar with, is gated on hardware feature support, often for hardware which doesn't exist yet. I'd be interested in how we get more coverage in that without having to run AG and emulation. Yeah. So if you are interested in what CKI is doing with code coverage analysis, and in turn that's something that I know we really want to leverage for automotive, you can take a look at the test. The links aren't clickable here, of course, but if you download the slides, all the links are there in the slides. So you can take a look at the tasks that we have for code coverage. That's in the upstream kernel test repo that CKI uses. So definitely take a look at that, or of course you can contact me or email the CKI project mailing list for more details. And Brendan, sorry to cut you off. I was going through the comments in the chat, so.
No worries. Yeah, so I guess there's a lot of different things here. So I think I wasn't aware that anyone was this far along with using coverage for anything in any public projects. I think this is awesome. So looking at a lot of different parts of the kernel, I think we're a pretty far ways away from making gating patches on coverage a reasonable thing to do. I think it's just with coverage being low, I don't think it's really realistic to ask a lot of developers to do that right now. I think, but I think it's a good ultimate goal to achieve. I would really like to see. I think it would be great if that's a place we could get to eventually. But I think, Kate, were you saying something?
Yeah, I'll finish your thoughts, and then I've got a couple of questions back for you.
But I think that if we could get, I think the real thing we need to get here right is maintainer buy-in. I think maintainers are how we're going to push these things. I don't know that having like a feature in CKI is really like the right way to go about this. I think what we need to do is make it clear and evident for maintainers so that way they can make decisions on it. I was gonna mention some of the other things, but before we change topics,
Okay,
Kate,
then so one of the things I'm sort of curious about is what is a reasonable threshold before we turn this type of thing on in your mind by default for each patch? How much coverage will we need to be seeing?
Well, so I think that's kind of another issue is I don't believe that there's like there's a correct coverage target to achieve. Like for example, I think 90% coverage is probably a little in most projects. So I've my original background, I worked on user space software, and I worked on a number of different projects, and I think the only code base that I ever saw that had like about 90% code coverage, they kind of gamed the system. They provided coverage for like generated code and stuff, which was not useful. And don't get me wrong, I love coverage. One of the things that was really cool on one of the projects that I did that I thought did it in a really healthy way is coverage reports were automatically uploaded to pre-submits. And you could then click on your code and it would show you incremental coverage. And you go, oh, the incremental coverage on like this particular change is kind of low. You could click and you basically could use it to help inform like what you should be testing and stuff. But on that project, we never set any hard coverage numbers. It was just sort of left up to the developers on the team to they developed a sense for what healthy coverage looked like. And I think it was more about looking at the coverage reports, drilling all the way down to individual files rather than looking at like what the overall combined coverage percentage was. So that being said, I've seen that most code bases, it seems like getting between 70 and 80% is achievable. But I don't know that I would use that for anything more than a rule of thumb.
Yeah, no, it's just I'm just wondering, it sounds like, can we look at tackling it, subsystem by subsystem with maintainers buy-in, basically engaging with the maintainers and to tackle it by getting some of the subsystems such that that becomes a policy in those subsystems that some of this stuff is turned on.
Yeah.
Is that a way to approach it?
Yeah, I think that's the way we'd have to approach it. But I think it would be awesome if we could do that.
Okay. I'm just thinking that, there's some parts that have been done, like Daniel's been doing the work on the formal verification already, for instance. And so some of those pieces might be closer than others.
Which Daniel?
Oliveira. Daniel B.
Oh.
Me, Bristol.
Yeah.
No, code coverage is important because the RFE, it doesn't tries to create a model of all the states of the system that the system can reach. We model the events that we expected from the system, and we need some kind of exercise in the system to try to exercise all the possible paths that it can take. In this case, the coverage is important to see if we covered all the paths that we expect on the system.
One thing I wanted to point out was we talked about gating the changes on targeted tests. It wasn't for code coverage analysis. Code coverage analysis and targeted tests, those are two distinct things. They're both working towards code coverage. But what CKI was looking to gate on was targeted tests. So that was about triggering meaningful tests based on the changed sources, looking at the files and the directories that are changed in the patch, and then running tests that relate to those changes based in the KPET database. So that's what they were looking at, not running GCov code coverage analysis and generating reports and looking to see how many lines are covered and crossing a specific threshold. But I think, what for automotive, it would be useful just to looking at it at a subsystem level and, periodically running tests and making sure that we're not only using it, but we're seeing a positive trend. So I think that's what would be important. I don't know about 100% of the entire kernel. I think that's not going to be achievable or realistic, but breaking it down by subsystem level and making sure that we are seeing a positive trend as we're running the reports and improving our test coverage is something that would be valuable for automotive and the kernel in general.
So there is a comment I want to.
Oh, go ahead.
Yeah. There's a comment I want to make, and so I think, and Daniel, correct me if I'm wrong, but so there can be like a very strong relationship between the runtime verification monitors and the code coverage reports. I mean, not only the code coverage is a way to verify that all the monitor states have been stimulated and reached, but on the other side, it's also the other way around. So basically, once we have a model for a certain subsystem, we are also able to explain why certain code coverage cannot be achieved. And I saw, for example, that there was a Will Deacon that made a comment about hardware feature support, right? So how we can get more, I mean, how can we increase the coverage? Effectively, once we have a model for the subsystem, then we are also able to know what are the states that that we are missing to stimulate, and by looking at the motor we should be able also to identify what are the inputs that would allow to reach these states. Is it?
Yeah, actually, RV depends on trying to cover all the possible states from the user space or from the users of the system, and knowing that we exercise the system is a good evidence that we exercise the model. Unfortunately, Mark Welver is not here anymore. He was at the previous session, and there was even some discussions about using the RV to monitor which paths inside the monitor it was taken by covering the code of the monitor to see how the system impacts in the monitor. Mark Welver would have something to add here. Unfortunately, he probably is in another topic. But these things are correlated by definition. For RV at least, it's necessary.
Hey, we sort of diverged, and Brendan, you had some other thoughts you wanted to bring in. So, do you want to continue? Or we went into that direction?
Yeah, I don't know. Like, I guess somewhat fortunately and somewhat unfortunately, I'm giving a talk later today with Shua, and I think you covered a lot of the areas that I was planning on covering. But that's okay. I mean, I think it's also good because it shows it's an important topic and that people are talking about it and thinking about it, which is really the reason we're here. So I think I think probably the most important thing we could do here is like come up with a strategy for how do we share with maintainers what their coverage looks like, and in an actionable way, but is also not noisy. And I think one of the things that kind of ties into that is your question about generating the reports being expensive. So I think generating the ports it tends to be expensive when running the tests are expensive. When running your tests is cheap, then getting the coverage is also comparatively cheap. I'm speaking from experience here. I'm the KNet maintainer, and shameless plug, KNet tests are pretty cheap to run, and we can generate reports for them where it's feasible to generate a report for like every change that's submitted. So like right now we run most of the KNet tests, or actually I think it's only about a third. We run a pretty large proportion of our KUnit tests on every change submitted to the K-self-test list. So I guess like most of the coverage we have right now is not via KUnit, and that's not something that's going to happen in any kind of near term. But I guess the point is cheap tests are one way to make the per change coverage achievable.
One of the things that's occurring to me here is as part of making completely agree with your points, no argument about that. But one of the features I'm seeing is missing is the requirements associated with a unit or a subsystem. And so I'm sort of thinking that having the requirements document along with the coverage and keeping that type of information together will become more useful, make everything more useful. So possibly as people are trying to figure out how we can start to make this practical to share the stuff with maintainers is also keeping a documented set of what the requirements are that are triggering the tests and so forth. So like the higher level requirements that are being aimed for. And quite frankly, so that if the maintainers are disagreeing with it or they're changing their minds on things, we have a way of tracking that too. Things evolve, right? We have all
Well-
5 patches, and then the patches are done by a reason, and what was the reason, and that's the requirement.
Right. Well, I think probably the best way, in my opinion, I don't know, you probably have more experience with like relating tests to requirements, but I think ideally if you can phrase the requirement in the language of the test, then the requirement, if the requirement ever changes, then the test automatically changes. It's kind of like coverage versus code.
Yeah.
Or sorry, comments versus code. Like it, comments become stale, but I think similarly coverage becomes stale, or requirements become stale when they're not somehow directly tied to a test or someone's very actively maintaining them.
Yeah. Rachel, do you have any thoughts there?
Yeah, no, that's the whole point, is we want to be able to track the traceability all the way down from the requirements all the way down to code coverage, and to make sure that we are, have that traceability. And that's one of the things that KPET was trying to aim for with the targeted testing. So features come in as merge requests. They're filed first, with Red Hat, they're filed first Mozilla, and then we have them in the form of a merge request, and then the targeted test is run to specifically test that change. But in addition, it'd be nice to actually see the code coverage on that, as a result of that test running on that requirement, having that traceability all the way down to the coverage level. So yeah, those are things that are being worked on. But yeah, it kind of goes back to the primary thought about having that it's expensive to run code coverage analysis on a patch level basis. But thank you, everybody. This has been a really good discussion, and I'll definitely check out some of the links that were in the chat. I appreciate all the great feedback about code coverage. It sounds like everybody's on the same page, that it's an important part of kernel development.
Thank you, Rachel. That's great. Thanks for sharing what you do at the CKI, and it's interesting to know how you are selecting. Also, if you have information on how you're selecting, determine which test to run, that might be useful to learn also for all of us.
Yeah,
Yes.
that's linked in the slides.
Okay.
If you're to download the slides on KPET DB source code.
Yeah. Okay, great. Thank you.
Thank you.
Okay, so next session is David Malcolm, ADIC, okay, kernel specific test coverage to GCC. Hi, David. I'm gonna make you a presenter. Right.
Cool.
There you are. Okay, so we are ready when you are.
Is there you switch the slides, or do I have to do that? Hold on. There we go, I think. And okay, I'll go for it then. Hello, everybody. My name's David Malcolm, and I work at Red Hat on our platform tools team. So I work on, over the last 8 years now, I've been working on GCC, mostly working on usability improvements. So basically improvements to how our warnings and errors look. Things like fix-it hints, spelling mistakes, correcting spelling mistakes, and so on. In the last couple of years, I've been working on this -f analyzer, which is a static analysis option, attempt to do static analysis inside the compiler, so you can find more problems at compile time. This talk is, or this session, or at least my slides, there's sort of a condensed version of a talk I gave in the GNU track, which is more focused on the GCC side of things. So I guess I want to, let's create a poll. Did you attend my Monday talk? And response true, false. and hopefully, did that show up? I don't know. Do people, hopefully people see the poll?
Yeah, the poll showed up. You should be able to see it.
Good, okay.
After a while.
I'm sorry?
You have to, if you want to post the results, there's a little button there. It should say post results.
I'm looking, publish polling results. All I'm seeing is done and start a poll. I don't know if anyone's actually.
It's on. It's where the chat would be, where the show it should show you all. The,
Polling. Yeah. User response. No. Okay. This is not. I'm having some issues with this. Okay. I don't. Should have practiced this. Sorry, everybody. Well, moving on. I'm going to be talking briefly about what this option does, the sort of capabilities of it, and how I've been extending it to work on trying to detect vulnerabilities in the Linux kernel. And I guess the caveat here is that I'm coming at this from the GCC side of things. I'm a compiler developer. I'm very much a newbie when it comes to the kernel, and also I'm not that knowledgeable about this is the assurance, the micro conference. So, and I'm not. I've sort of been coming at this from the point of view of compiler warnings. So, for example, my detection can have both false positives and false negatives. It can miss things, and I'm wondering to what extent that's a deal breaker within this community. Anyway, I worked on I added this new interprocedural pass to the compiler to GCC and GCC 10, and it's really only useful for C code right now, I should say, but that's okay because we're talking about Linux, and it does a much more if you turn on this option, it does a much more expensive analysis than we've typically done for compiler warnings in GCC, and can greatly increase your compile time. But then there's a whole bunch of compile time warnings that are associated that are sort of keyed directly off of this analysis. It uses amongst other things, it allows you to attach state machines to the analyzer so that you can analyze. The one example is analyzing heap state. So you could, if free is called on a pointer, that pointer is transitioned to the has been freed state, and if you call free on it again, that's a double free. And so there's sort of a infrastructure for running state machines as we interprocedurally explore the paths through the user's code. And the slide I've got shows the various warnings that or at least numbers the various warnings I've added. For GCC 12, which is currently under development, feature freeze is in November of this year, and we'll release in the spring of next year. And the main one I've added, change I've made, is I'm tracking whether values are initialized or not at the per bit level in a path-sensitive interprocedural way, which is much more precise, I guess, than the existing GCC warning for uninitialized values. And so, as I said earlier, the analyzer is neither sound nor complete. I'm coming at this from I make a number of trade-offs in terms of how I'm modeling state inside the program as I'm exploring the paths through the code. So I try, for example, if there's a memory allocation versus a stack allocation, I will split the analysis on that path and keep that split until that pointer it goes out of scope or is dead, in fact. So I try and keep interesting paths alive, or interesting splits in the state, for some definition of the word interesting. But I'm using a bunch of heuristics to try and basically to try and ensure that the analysis terminates in a reasonable amount of time, and indeed terminates, because you can't just arbitrarily explore every path and every state in the code, because it explodes exponentially. And so there are various ways in which the analysis can fail to find real problems, and also can mistakenly report false positives. And as I say, I don't know how much of a deal breaker that is within the, you know, from a the functional safety community perspective, but I am new to the kernel, and this is in many ways I'm trying to get feedback on what's useful and what isn't here. So in the spring, I started looking at historical security vulnerabilities in the Linux kernel, and I was thinking, well, I've got all this infrastructure for finding, well, you know, classic problems in user space code, but you know, Red Hat, we care a lot about the kernel, and I thought, well, how can this benefit the kernel team? So I was looking, and I reckoned there were two broad categories of vulnerability that would be relatively easy to extend the analyzer to detect. One is information leaks, where uninitialized values are copied from the kernel back across into a trust boundary, into say user space or across the network, and that allows an attacker to do reconnaissance as part of a wider attack to get information about, say, for example, where particular things are located inside the kernel, which particular pointer addresses. And the other broad category is taint detection, I call it, like Perl's taint mode, but for looking at kind of data flowing the other way. If you've got values coming from user space, for example, as system calls, as ioctls, or potentially from a hostile USB device or from the network, can we detect that trust boundary and detect, do those values get used without sanitization, and get used as an array index or a divisor, so that an attacker can inject a divide by zero into the kernel. And I foolishly thought that info leaks would be relatively easy to detect and be a good way of sort of dipping my toes into the kernel source code. And so I was exploring that, and then sort of build up towards that. So the taint detection seemed potentially higher value because you can actually use it to directly do denial of service attacks and get root, as opposed to just doing surveillance for or a reconnaissance, I should say, for another attack. So a trivial example of a historical example from 4 years ago in info leak. We have a struct with inside a driver with some fields, and hopefully this code is well. Basically, we create one of these this struct on the stack. We populate all the fields, and we do with some values, and we do copy to user, which is a classic sort of pattern in driver code. And there's a vulnerability here, which so I have a heavily patched version of GCC 12, or GCC trunk, I should say. Most of my changes that I made are sort of infrastructural changes to my analyzer work, and those changes are in trunk for GCC 12. But I've got some extra patches on top for kernel specific warnings, and here's the warning about that. It says, rather verbosely, potential exposure of sensitive information by copying uninitialized data from stack across trust boundary, the CWE code, and the command line option -w analyzer exposure through uninit copy, which is rather verbose. But in more verbosely, I try and show the pertinent aspects of the code. Here is where the on-stack buffer is created. Its capacity is 52 bytes. Here is where in the code the copy to user space happens. And you might reasonably think, well, the code's initializing all the fields. What's the problem? And so, and the problem here is that there's 2 padding bytes. And so in my warning, internally it's looking at the per bit level, at the particular path through the code that it shows via ASCII art in the last slide, that it knows which bits are uninitialized on this path that have been copied to user space. But to present it to the user, I sort of iterate through all the fields in the struct, and I try and show which fields are fully uninitialized or partially initialized. And similarly, here we have padding, and here's the struct declaration. It's after this field of the padding bytes. I can also generate a fix-it hint, and GCC can actually generate a patch from that to fix the problem. A similar example, this is a vulnerability from 10 years ago, which I've had to heavily edit to get it to fit on a slide. And so we have a struct that's created on the stack. It has a slot number and it has a pair of slots. We populate that from user space with a copy from user call. And we get a pointer to that on stack buffer. We do a bit of sanitization, and then we modify another data structure in the kernel using the value we just got. And there's a vulnerability on this line, which I told you in if you attended Monday's talk. I don't know if anyone can spot it. And the vulnerability is that we're only validating that the info num hasn't exceeded the upper bounds of this array, but it's actually a signed integer, and so the attacker can supply a negative value, and therefore this write is a write to an attacker-controlled arbitrary location inside the kernel. And so my patched version of GCC can detect this. Again, I did simplify this case, and right now it doesn't detect the actual historical code for this vulnerability, but it does detect the simplified version. So yeah, warning, use of attacker control value, so star info.num, which could probably be improved in array lookup without checking for negative. And I structure things so that I have various different wordings, and I'm trying to express exactly what the problem is, like what was checked and what wasn't checked. So yeah, without checking for negative seems to be the best way of expressing to the programmer that what's going on here. And again, it shows the path through the code with the sort of ASCII art sort of, we follow this branch to get to here, and when we follow that branch to get to there, then that's where the use happens. What it doesn't show, and what I hope to show, is why the analyzer thinks that this is attacker controlled. And I mean, it should basically highlight, I guess, that the copy from user happens here, and therefore at that point, sbuff is attacker controlled, and therefore at this point, info-num is attacker controlled. So that is one error I do want to fix. And so it gets into the kind of, where should this code live? Because this is, I mean, right now my branch has my GCC branch, which is, it detects, it's got some very kernel specific hacks, like special cases, copy from user, copy to user. And I've been looking at, well, can I make this less kernel specific and do things so that other projects could use it? And also, if this is really just kernel specific, it probably shouldn't live in the GCC source tree as I upstream this. Where should it live? Should it live as a plugin in the Linux source tree, or can we express sort of ways of marking the code to express, well, what is the boundary, the trust boundary? And so I've got some ideas on this slide. We have an existing attribute in GCC.
If you excuse me, so it's already annotated as __user, as to address a different address space.
Yeah, potentially that could be done. We could use that. That's a good idea. We could. I think right now, by default, GCC turns user into it goes away. It becomes white space. We could turn that into a GCC attribute, and it sounds like let's have an attribute address space for that. I think GCC already has an attribute address space, and it uses it for something slightly different. Or I have dim memories of looking at it a long time ago, and something wasn't quite ready. So maybe that's something to do, is to reevaluate whether GCC can use. We can provide a attribute address space that certainly the analyzer can pick up on, that given a suitable configuration of the kernel build,
Yeah, I mean, the underscore user you have right there is already all over the place in the kernel. And that's exactly what you want to use.
I guess the issue here is that the analyzer needs to know that it sees there's a function with a particular name, whatever, and it's taking a user space parameter and a user space pointer and a kernel space pointer and an unsigned long. It needs to know that this is a copy, and the semantics here are right now is that the analyzer sees a copy to user and says, okay, if I see uninitialized data flowing across this, this is a copy
just so I express your question, because you're going on, I'm not sure if everyone gets it. So the question is not about annotating the variable. The question is annotating the function that does the copy.
Yes.
So we need to have some sort of annotation that says copy from user, like sort of like a print. What we could use is the printf format that we have, where you get warnings for printfs, and you could actually make anything that uses a printf format to warn that if the format doesn't match the parameters. So we could have something like that, an attribute above the function to declare that copy from user takes this guy to go this guy. Would that work?
Yeah. Well, on the slide I've given, the attribute is linked to the function declaration as a whole, but the numbers are expressing which argument number of that function decal it's referring to.
Yes. I think we could do something like that. Just we use it for printf right now.
So basically the analyzer needs a way of saying this is a copy across a trust boundary, where either we're copying data from the kernel back into user space and we want to complain about information leaks, or the other way around, the copy from user, which is we're getting data that is potentially hostile. We want to treat that with care, and we want to complain if it's used without sanitization for array indices, sizes of allocations, so on and so forth. The one example, another syntax I came up with is I invented an attribute tainted, and if I put that into syscall define x, it means basically every system call. My objective is this anything marked with attribute tainted, the analyzer can say, okay, this is the inputs to this are hostile, both direct inputs and one level of indirection. If you're provided a pointer, and therefore, if you mark the system call macro with that, all system calls across the kernel get marked with just that one line of annotation that don't trust the inputs.
Can we, instead of using tainted, could it be called like untrusted?
Yes.
So tainted is used for lots of other, is pretty ambiguous if you ask me. But untrusted would be very.
It's the common name for doing data flow analysis, though. Tainted is the right name here.
But we use tainted within the kernel all over the place for other things.
That's true.
Yeah, I mean, again, it's the sort of where does this code live? Is this how much of this is going to be in GCC itself? How much lives in the kernel source tree? I read of LWN on LWN a couple of months ago with Linus saying how much he hates GCC plugins. So maybe GCC plugins are a non-starter, and I want to try and express all of the semantics with attributes
of a GCC. I mean, if it goes into GCC proper and tainted is the proper word, that's perfectly fine. What we would do, we would just define it. Maybe we would define a macro called untrusted and use attribute tainted. So in the kernel, we'll just use a define.
The other place I found I could use it is in fields of struct declarations, where you have this pattern where you, for example, I think it's the ioctl callback in the inode, and there's a store callback in config.s, and basically anywhere where you have these callbacks that you register implementations for, you can add the attribute to the field declaration, and my implementation basically sees any function that gets registered as a callback handler in one of those structs. The analyzer says, aha, this is an ioctl handler, or this is a store handler or whatever, and applies the attribute and the, you know, assumes that the inputs are untrustworthy. The idea being that you can detect this is like this is handling data coming from a potentially hostile USB device, or this is coming, you know, this is coming from an ioctl, without having to do so much a whole kernel into, you know, link time into procedural analysis of that taint or untrustworthiness, if you will. You can kind of get it immediately from the, oh, this is an ioctl handler, beware, if that makes sense. Yeah, I say I'm kind of a kernel newbie, so I'm hoping that this all makes sense. Yeah, so I'm kind of moving on. Yeah, the only kernel code I've written, I tried to write the world's worst kernel module. I have a bunch of unit tests in my branch with lots of sort of reduced C code from the example vulnerabilities, and I've been sort of and so I've got unit tests. So does the analyzer find this stuff? But also I've got this antipatterns.ko on my GitHub to try and verify the analyzer does also find these things on a using the system kernel headers with the regular configuration, and yeah, and that works. And yeah, as I say, ideas for other tests most welcome, because I'm sort of coming at this from the you know, with my compiler hat on, rather than sort of knowing things from the kernel point of view. And I've written an automated script that basically grabs my customized GCC source tree, builds it, and then builds the kernel, or builds a kernel on top of it. It takes about 4 hours to do the kernel build with -f analyzer turned on a decent machine, which is I guess a pretty big slowdown. And I've been running it on recent Fedora, RHEL, and upstream kernels, and I got it to, with at least info leaks, to have 0 false positives and 1 true positive, where it's found an actual vulnerability in the all-yes-config kernel, something that we don't enable in Fedora or RHEL, which I've reported but isn't yet public. And for that reason, currently this code is sitting in a internal Git. Well, most of the code is in GCC upstream, but the kernel-specific parts are currently just in a repo internally at Red Hat, because there's an issue of what is responsible disclosure with a in the world of, you know, free Libra open source static analysis tools, because it's going to find 0 data if you run it and it finds an unpatched vulnerability in the kernel. That's not good. I'm kind of wondering what the process there should be. And so yeah, in terms of the current status of this, lots of enabling work, basically, or like the tracking of uninitialized bits. That's all in GCC trunk, and there's a new warning there relating to that. But yeah, there's the sort of, what color do we paint the bike shed in terms of what should the syntax be like, and for marking that boundary between user space and kernel space. And indeed, hopefully we can express all in a sort of, with general enough semantics that it can all just go into GCC and not live in the kernel source tree, I think, or with a very minimal patch to just with a few attributes here and there. That's why I like the doing in system call X or whatever, because I don't want you to have to add annotations everywhere throughout the kernel, because my experience is that users hate doing that. You know,
hey, David, I think this is a micro conference, so we want more of a discussion now. So
yeah, I'm sorry.
So David, I was going to say that you have several questions if you want in the chat, questions and then comments. So if you want to take a look at them and see if maybe some of your questions are already answered, the ones that you're asking.
Yeah, where are we here? I see Case Cook, if I'm pronouncing your name correctly. I apologize if not. Plugins should go away. Everything, yeah. Untrusted inputs, attribute tainted. Yeah, that looks. Oh, and sys module taint. Oh, I see. You use the terminology tainted kernel for if a third-party module has been loaded,
among other things. Yeah, there's a whole bunch of different taint flags. So from the perspective of data flow analysis, tainting, this is cool. I would like to see the taint tracking actually work. The issue I'm concerned about is that right now, without LTO, this seems like it would be very, very shallow in the sense that it wouldn't leave like one function. So having that information actually flow down across the whole, function call graph, where you can say, oh yeah, these are the structures that got written to the heap that contain the, totally unchecked data from a device, from a network packet, from syscall information. I think that's where we really want to have all those checks, and I think that it seems like LTO is going to be required for that.
Yeah. The analyzer has some. It's basically a proof of concept of LTO analysis, but if you try and use it on anything other than my toy example, it just explodes. So that obviously would need fixing.
But if we have enough annotation across function calls, I mean, when you have a structure that's passed to a function call that has, this is unsafe, it should handle a lot more cases, even without the LTO implemented. Is that?
Yeah.
To some extent.
But,
I mean, the problems I've seen are where, you do a bunch of deserialization basically, and you're putting data from one place into another, and far, far away, you take something back out of the heap and use it as an array index or something. And it's like, oh, that array index actually originated from some blob that came from user space, but that was, 3 syscalls ago, and it was stored here waiting to explode, stuff like that. So that like long-term taint tracking, is definitely something I would like to see, but it may need to be more runtime checking than static.
Yep. Well, I think I wouldn't want to stop this work. I like what I see here. I think it's definitely positive. Positive. I would, and I mean, for false positives, I guess the best thing to do is if we have a way to quiet it, maybe especially since Linus adds that -w error message in there. So now a false positive could fail the build if this is enabled. So. But I think this is something we definitely want in the kernel.
Yeah, as far as false positives, I mean, we have a long history of enabling things globally, is we just slowly fix them all, whether that takes 1 release or 10 releases, just go through it till they're all fixed and then turn it on. So yeah, I'd like to see it.
And like I said, the attribute stuff shouldn't be a problem. We use macros extensively, so we could always use, I guess, like we mentioned, the taint, we could call it something else. So what's in the kernel will be called something different just because we have a macro defined specifically for it. We do that all over the place.
Yeah. And I guess there's the way I've structured it is with the -have analyzer as a compiler warning. Is that it sounds like LTO is really what you want, but is it still useful that way? I mean, the idea is to at least get a shallow. My hope is that if I can get it fast enough that you might want to still turn it on as you're writing the code. Is that feasible, or is that something people do? I mean, what sort of slowdown is the pain point in terms of compiler
it'll be
builds?
a config option probably. So so those that don't want it could just turn it off. I have automated builds all the time that I don't really care about. It takes 13 hours to go through all the builds that I have, so I just kick it off before I go to bed and let it run overnight, and it gives me all my error messages. So that's something that I don't think is an issue, as long as you could disable it for those that are debugging something else, so they don't want to have a slow build. Which, like I said, if it's an option, we have the kernel's highly configurable. We can easily just keep it off as a config option to enable this. So that's what I envision. I don't think that would be an issue. I think there was something else that I mentioned that you said. I can't remember what it was. Lost my train of thought. But no, I think this is something you should pursue. Even if you, I don't think you have to worry. A case that you want to make a comment about his worry that this might expose the 0-day. I mean, we have sparse. Are you familiar with the sparse utility that we run? So we run sparse all the time that does something similar, but you have to run that separately.
Yeah, I mean, we have what 800 0 days listed on the syscaller dashboard.
So don't worry about the 0 days.
That's the point. It's supposed to find the problems. So if it's just going to find one problem, we fix it. I mean, you already sent one, so you just that's the process.
Yep. So once if you were to push this out, I'm sure yes, the black hats will use it, but the white hats will as well, and we have we'll be testing it.
No. The black hats already know.
Yes. Yeah.
They already
so basically,
have these tools.
Yes. They have their own tools that they're not sharing with us. So yes, don't be afraid of sharing this with us just because you're thinking that people will abuse this. Those that want to abuse this have their own tools that's already doing this.
Yeah, I mean, it's maybe it's the gray area there because in terms of analyzing the paths, there are parameters you can use more CPU time to say I'm going to just explore deeper if the state seems to be exploding. So potentially there's an arms race there between how deeply you want to explore versus anyway, I should let other people talk, sorry. Where are we?
Okay, so any more comments on that?
No, I was just leaving my video up since it takes a lot of clicks to start it again.
I have a question, which is how best to integrate this then into the upstream kernel testing. You mentioned a configuration. I'm presuming I should add a configuration option to the kernel to add -f analyzer or something.
My assumption is that if you just create this for us, in case there's lots of people that could just say. So you don't have to learn unless you want to learn how to do all this and have your kernel contributions. If you just have this, we'll find a way. Just send it to us and we'll get it in there.
Great. Okay. Thanks. I guess the other is the opportunity cost, which is there something else that I could be working on that would better benefit the kernel in terms of security or because I mean I'm a GCC developer.
Are you coming to Friday's kernel security features and compilers thing?
That's my plan, yeah.
Okay, good. Then that's the place to be.
Cool.
So 1 minute left.
I don't know if Peter Zylstra wants to come in and make any statements.
Okay. So, David,
just looking over the chat. Did we cover everything that was said in the chat? I'm just looking through it now, and I think so.
I think there are some other comments that you can look at and then continue the discussion. Also, we're coming up on a break anyway.
Great. Okay.
Just a minute.
Cool. Oh,
thank
you, everybody. Yeah. Thanks.
Thank you, David. Okay, so now we are having a break, and the room, anyways, it will keep on going, and we will reconvene in 20 minutes.
If you want to create a poll, you can, Gab, and for us when everybody comes back.
Actually, I'm doing it so you can be center.
Go for it, Steve, and then just switch over to the click when you're back slide.
Try it again. I'm hitting next slide and it's not letting me. There we go. maybe it's, there we go. We're on a break. There we go. And then you said in 20 minutes, so quarter after.
Yep. Okay, thanks.
So we'll start in 1 minute.
Okay, so I don't know how many people are back.
Well, you took presenter from me, so I lost the poll.
Ah, so Lucas, you can see the poll, I guess.
No, I think the poll is reset, turned off. It had 15 people back when I last looked. And also, it's easier, by the way, just if you switch to the next slides and not make it put up to the presenter to find their slides, it usually runs easier that way.
Okay, now I think the presenter found the right one.
Okay, should I just start? Or is there an intro to anything?
No intro, I believe you can just start.
Okay, yeah, sure. Okay, so what I want to discuss, I think it's related to dependability and assurance, is the question how we are dealing with bugs in the kernel. So what, and I think we'll have to start with the question, what is a bug? And then look into how do we actually track bugs and what is the impact of a bug. And I'll show a few examples, and hopefully throughout this discussion we can actually come up with a few more aspects that I didn't mention. Yeah. So the first question is, so what's a bug to start with? And I just put together a number of examples that you can come across that one person might consider a bug, another person just might consider it some kind of code improvement, but doesn't really consider it bug in their own word, right? So something that we probably would all consider a bug is a possible race condition that we can hit, or a failing test case in XFS tests. Other things that only security people care about is information leaks from the kernel. We heard yesterday in the testing and fuzzing microconference, well, the system call can actually change the arrow no value it returns. And we still believe that that system call is backwards compatible. Others might say that's strange, that's changing the specification, so it's a bug. And of course, you could even go further and say, even a spelling mistake in a comment in the source code is a bug, or a static analysis finding that someone should address is a bug, or a compiler warning is a bug, or even a code snippet in the documentation that doesn't work at the moment is a bug. So these are all different examples that we might name a bug. And what I want to do is define what a bug is in the widest sense that we can think of. And I'll do so by saying, well, every commit that doesn't add a feature is a bug fix commit. And the initial trigger that motivated that change is the bug. So we have something that's somehow a locally bound aspect, somehow related to the content in the kernel repository that motivated someone to do a change, and it's not adding some significant new functionality for any stakeholder. That's what we consider a bug in this further discussion. So now we're going to look into questions. who is actually identifying bugs, how are bugs reported, how are bugs tracked, who cares about specific bugs, and what actions and what what actions really happen, how fast, how reliable are they. And I think the question that we want to understand is which tools really exist in this community for bug detection and for bug tracking. And a bug detector is right, it finds some kind of bug, as I defined before, some aspect that should consider a fix on some version, some config, and the bug detector can also check afterwards if a fix was somehow addressing that point or not. We have a bug tracker that collects all those bug reports and that relates them to each other, aggregates information, and reports that further to the upstream development community. So for maintainers or bug fixing developers, trying to get some kind of summary of what's currently known, or reporting updates on some status. The bug is now fixed, or it doesn't appear anymore, or there's something new. And of course, downstream users as well might be interested in, okay, what's actually, what has changed from one version to the other, and is that a reason to actually do an update? Okay, so that's the basic flow that we expect around bug reporting and bug tracking. And we'll look into 5 examples where we use very different tools as of now, or actually don't have tools in place at all. So we'll start with a bug report by a human kernel user, look into how does that differ from bug reports by an automated testing system. What is a bug report when it's about a compiler warning? And what's a bug report identified by fuzzing? And what's the bug report for static analysis? And that should give us a rough overview of what's available in the kernel. Okay, so let's start with a bug report by a human kernel user. Basically, we have a documentation page that guides a human how to report something they encounter. You can either use Bugzilla kernel.org for some subsystems or send something to regressions list Linux kernel. Yes, there are some potential future tools that Thorsten Lemhus is envisioning to allow bug tracking of those aspects. Regspot is kind of his idea in that direction. Then we have bug reports from automated testing systems. I think then we also have a number of tools available: Lava, Fuego, Kernel CI, and KCIDB, and various others that build kernels, that test kernels, and then report the test reports. But what is unclear to me is actually how does backtracking work for those, right? Is there a suitable identifier once you see a failed test? And you can consider that, give that some kind of bug identifier. How do you actually show that a bug is fixed? How do you record that bug fix and link it against a commit? So that basically others also see, okay, this isn't just a coincidence that this failed test is now working again, but it was actually done on purpose by a certain change. Similarly, for compiler warning bug reports, there are a number of resources that basically already provide something. Stephen Rothwell provides email notifications on Linux Next. There's the Clang built Linux GitHub tracker, where they collect compiler warnings on Clang. You can look into kernel CI build logs that reports feedback on compiler warnings, and there's kernel test robot that provides you feedback as well when there's a new compiler warning. And here the challenges that we are seeing is that there's question on, is that actually parsed precisely? How's that automated? How's that tracked? And how do I actually get a consistent report from those various tools? Or even, are they reported at all to the developer? Okay, so maybe two more. Fuzzing also identified the problem of having a bug report and tracking that. For Syspot is basically a bug tracking machinery by itself, because Dimitri basically identified that for the bug tracking he wanted to do with his machinery, there was nothing suitable available. And that is for the one instance that we know. If there are other syscaller instances, it's actually even more complicated to understand how they could report and manage bug tracking when there are so many various non-unsynchronized Syspot instances running. So I think the challenge is, can we actually provide something suitable before the next tool comes along and tries to rebuild such a tool again? And yes, we've seen also static analysis bug reports. There's a Clarity and the Clarity bot that Colin King and Keys is basically working on, and we've been working on some early testing with an open source tool from Ericsson that also tracks static analysis findings over time. Yes, so once we've seen that we actually have all those different tools for bug reporting and bug tracking, the question is really, how can we make that useful and aggregate that information so that maintainers can make choices on, okay, what are they actually going to integrate? What are they going to sit in a pull request? And where can they reach out to the original developer and ask to refactor something if they get feedback from those systems? Yeah, so here we've now seen an overview, and I think with that I actually want to open the discussion on, let's say, other tools, resources, use cases that I didn't describe that are maybe similar to those, that are completely different possibly, and of course, where's the potential for synergies? I mean, I see already Xion is pointing something out in kernel CI, but yeah, it would be interesting to find out how the landscape in the future could look like, and especially how the community members that aren't, let's say, doing development or maintenance work can actually assist by just helping in tracking bugs and connecting the dots between what bug reporting tools or bug reporting humans provide and what the maintainers pick up, and how that evolves the code base.
Lucas, you do have a few comments and questions in the chat if you want to take a look.
That's great.
Thank you.
Okay, yeah, otherwise I would open the discussion as I read. Yeah. Yes, so maybe I'll just read out what the case wrote. So I think one of the challenges is, of course, we have all those bug reporting tools, but they are triggered too early, or no, they're triggered too late. So once it's actually integrated, and the question is, how can we build something that the CI systems and all the bug detecting tools that we have are fast enough to warn the maintainer not to take a commit before it's actually on Linux Next.
Well, I don't think the problem is Linux Next. It's we don't want it in Linux history. Linux Next is a perfectly fine place to have it for testing the bug fixing.
Well, but
prefer it doesn't get the next.
Prefer not to get the next, but still, you know, if it gets it to next, I thought next was basically where you do all the integrated testing and such.
But Stephen, if I say, well, a bug is a spelling mistake in a comment, and you see there's you take a patch, it's already in your tree, and then someone comes and says, oh, here's a spelling mistake in this comment. You're not going to say, well, I'm going to retract what
Correct.
I did because of that, right? So you might have done a different decision beforehand and said, okay, wait, this isn't perfect yet. Can you still rework it? But right, there's already a different threshold at that point. When it is in Linux Next, you're going to say, well, now it's there. Please provide another patch on top. And I mean, that's great for statistics. And yeah, we have 50,000 changes every 2 weeks, but it's really
But like I
a
said,
lot of
are we
noise,
worried?
right?
I mean, spelling fixes, that's just for those reading code. Yes, it's a bug. We should have spelling fixes in there. But I'm not worried about security problems because of a spelling mistake.
I'm going to say typo squatting, Steve. Typo squatting is a known attack vector.
Okay, I have to go look that up.
Okay. But yeah, spelling mistakes, you know, have been used in the past. Usually at the component level, but there's nothing to say that someone can't get clever in the kernel too.
Are they checking to make sure that if it's only text that's being changed, it's pretty easy to tell that from a patch? Mark, are you trying to say anything? See your name popping up.
I was going to jump in, but after you finish this.
Go ahead,
Yeah.
Mark.
Go ahead, Mark.
Yeah, and now I got slightly. Yeah, so one of the things that's been going on, the thing that's been going on in the chat is a discussion of can we get any of this to the point where Linus is checking it and refusing to merge things that are breaking some critical set of tests?
I think another question is, what is Linus using to test, before he pushes out to his tree?
From what I can tell from this recent one, it's that he just types make in his Fedora shell, because he was the only person who hit a Lang setting bug. None of the other CIs did.
him being the only one that hits something isn't proof that all he does is make.
So it required being in a interactive bash shell, and all the other CIs were setting the standard CLang or having it unset. So he wasn't in a, well, it didn't appear to be inside a container. But anyway, it doesn't matter. If we had a common set of CI that we could point to in merge requests and say, look, this all passes, no warnings for all these configurations, please merge my stuff, Linus might be happier.
Isn't that what we basically 0-day does? I mean, every time you push to a branch?
Kind of, but there's no good summary.
Yeah, Isn't that what we do? Isn't that what we do for stable though? Stable releases come out and then several test strings go test them. So you're really talking about something similar?
Yeah, I think that would get us a long way. I mean, Greg does. I mean, it's not great CI, but it's massively better than what we have for mainline itself.
Mm-hmm.
Right. I think what got brought up in chat somewhere here was just sort of having a kind of a regular way to put that into pull requests. Like, here's the matrix that I did testing on. You can see it here, and that doesn't mean everyone has to use the same CI, but at least if there's some common way for us to say, here are the the configurations that got tested and we see no new warnings or whatever. And that way there's sort of a common format in the pull requests that can be scanned by a human and say, oh yeah, okay, that looks good.
I wonder if we should have the pull requests go like when you do a pull request, if we could automate it, so all pull requests to at least Linus or maybe to well, in Linux Next it happens, but maybe to Linus that it goes to an automated session. Of course, this will be the Linus's say to do this or not, but if we had an automated way that everything that goes to him goes through some sort of test suite first before he actually even sees it.
Ideally, that information would also be in the patch that what testing has been done. Some maintainers push for that information, some don't. So that would be another indication that what kind of testing was done on a patch itself. However, it doesn't mean that we are not going to find problems when we are trying to integrate in the Linux Next, right? So yes, pull request, doing some kind of sanity checking on pull requests, I think would be a good idea.
Well, then, okay, if it's Linux Next, the way Linux Next gets pulled in is I push it up to my 4next branch, and then Stephen pulls it into his. Well, if Stephen has all these tests, so so maybe every branch that he pulls in,
you can't run any more tests on Linux Next.
Okay.
Like there's a 24-hour cycle in which you've got to go from Linus's tree to Linux Next, involving a lot of builds already. And at some point, the Linux Next maintainer needs to sleep and eat.
Well, I'm saying this should be automated, not something he.
Yeah. So the problem is that every merge in Linux Next, you don't have the tree until you're partway through the merge. You need if you're going to do an integration test, you need to be at the point in Linux Next where you're about to pull in the tree, test it, and then you see what happens.
Right, but I think we can have the machinery happen after that, right? There's already the existing integration work that happens to produce Next, but then once it's produced, you throw it at the machinery.
Yes, absolutely. We should be testing Next itself. Yes, absolutely. I'm just saying that the idea of having Stephen do it as part of the Next merge is anything that gets added to the Next merge process, it needs to be very, very, very quick.
I mean, don't we already do Next testing though? There is a lot of testing that happens, and it depends on when, I guess, maintainers push it to Next, right? Do we let it soak for a few days before we send it to Linus?
Right, there's tons of testing, but there isn't a common way to describe to Linus, here is what passed. Like, these are the things I am looking at as a maintainer for this tree, and it passed these things that I care about. Here is what I care about. That way we don't have to depend on a single specific CI or anything, and then Linus can say, oh, you don't seem to care about this thing I think you should care about, etc. So he can analyze what got tested for that particular pull request.
this sounds like something that should probably be brought up in the maintainer summit or something, asking Linus. But
I agree.
I mean, I have my own little test suite that's specific for ftrace. Although because ftrace is so broad, it actually usually finds bugs all over the place. It just does crazy tracing. I just kick off a bunch of crazy stuff and trace it, and that opens up. Sometimes the tracing slows things down. It opens up race windows in other areas and triggers bugs. But the whole process takes between 8 to 13 hours to run for me. I mean, I could just say that's what I do. I think Linus knows what I run. Every maintainer is going to have a different test suite that they're going to focus.
Absolutely.
On the other end of things, I don't have very much of the hardware that my subsystems support. So my any testing I personally run is an absolute joke, really, because I just physically can't run a lot of this stuff, and I'm not going to start either because I don't really have space to put that much hardware in my home.
And I think one of the challenges is, right, even if Stephen says, well, Linus knows what I'm doing, maybe there are 2-3 other people that do also know that. If that evolves or if that breaks down, there's really nobody that can that is informed, right? Because you're basically, maybe you decide I'm building something, I'm adding something to it, and since then you actually improved the quality of your pull requests in some regard. Nobody's going to know in the initial state, right? Because you don't have a reference where you point to and say, look, here are the test results in some way that you can look at them. And again, right, when the dependability track here, that's one of those questions. How do I provide evidence that Stephen actually did that kind of test? Because you don't want me to ask you with every git pull, oh, Stephen, did you do this again the way you did it? Right? That's just going to be annoying for you. Someone asking you all those questions.
And I mean, we do have the self-test there. That's one thing that's part of my test suite is always run all the self-tests. And
You
I'm
can
sure
get the self-test running. Well done.
Well, no, I run my own self-tests. I have the self-test for what I care about, and I believe maybe like Mark. I don't know if there's a way of saying, is there a way for when you get patches from someone who has the hardware, can you just say, did you run these tests? So maybe, I mean, the question is, do they? They could say yes and not. That's another problem. Is how do we know they ran those tests and just didn't just say yes?
Yeah, I don't personally have test suites, but you can do that. But I know the V4L people and the graphics people have some pretty good stuff already. And like you say, even if you have that requirement, there's going to be a trust thing where they could just be lying.
So Mark, for your issue that you're facing, a hardware self-test, K-self-test doesn't have a whole lot of hardware coverage, right? So you can test it, but run self-tests and such, but you won't get a good coverage anyway for the issues that you're looking at.
Some of it I could in principle, although I mean I think for some of it KUnit is a better fit, but same principle, of course.
Yes, you're right. Media V4L has a better test suite, and when I do something there, I usually attach a test script in terms of being able to test all the corner cases, media being the complex subsystem, one of the complex subsystems. But it would be nice to have maintainers have a checklist and say, this is what we would like to run, we would like you to run when you send a patch. That would be the first step, and then slowly it could be go all the way up to pull requests. So you kind of have to layer this in as well. That's what I think is an effective way.
So I have a question, sure, but isn't that, I mean, you talked about a checklist, for contributors, before they submit a patch, to make sure it is tested. So basically, that would rely on just on the word of the contributors, right? So basically, what you're saying, I mean, it's different from the principle of getting patches, right?
So that's the first step, right? And we do have an expectation that when somebody sends a patch, that it is tested to some extent. It might not be a complete test. For example, networking subsystems, they rely on having self-tests pass on those tests. I think XFS probably tests need to be run for file system changes. So that's kind of what I'm talking about. If we know, sometimes I fix a bug in a subsystem, and then I do not always know which tests should be run, other than the obvious ones.
So I guess there are two kind of problems here. One is, how do you know what tests you run for what subsystem? And then you could just have something like an entry in maintainers that's like testing, run this script or read this doc for what to test for this subsystem. And contributors can use that. And the other problem on the other side is, okay, now that a maintainer has a patch that they're deciding whether or not to accept, or Linus has a pull request he's deciding whether or not to accept, does he have to rerun, or does that maintainer need to rerun those tests themselves? And is there a greater set of tests they need to run on a greater set of hardware, or ask someone else to do that? How do you prove that? So there's the what tests do you run problem, and there's the how do you prove that tests have been run and who runs them.
And I think, right, in extending that thought, right, if you will get some kind of feedback from those test reports, some might be, well, some might be negative in something failed, but let's say we run a spell checker on it, something is going to say, well, there are thousands of spelling mistakes. What is the threshold for Linus, right? I assume Linus is not going to say, well, okay, everything went through, but you have 1,000 spelling mistakes, so we're not going to make progress here. But of course, just trying to make aware where is the threshold for certain things, especially because we have tools that point out, let's say, rather minor issues that eventually get fixed. And that's what we usually call trivial fixes, right? But eventually someone's going to come across and debug the maintainer that there's a spelling fix to be done. There's some dead code somewhere. There's a compiler warning with a very special thing.
Well,
So
I mean, compiler warnings I usually take a little bit more seriously than just a spelling fix. But with spelling fixes, if I push to Linux Next, will I rebase? No, that's exactly it. But if someone sends me, I would say just give me another patch and apply the spelling fix before it goes beyond Linux Next. That's fine.
But that's your personal judgment, right? And
well,
I think
why would it be anyone else would have an issue? You mean Linus will not pull something because of a spelling fix?
Well, Linus not, because right, Linus has a different threshold that you agreed with him, but also Linus has some kind of understanding, and if he wants to move that forward, there has to be some common way of figuring that out, communicating that, right? If he decides tomorrow to say, okay, I'm only going to take something if you don't introduce new spelling mistakes.
I highly doubt he will do that.
Yeah, because the community would break down. But basically, right, there are aspects that you agree on that are quality issues that are not a blocker.
Yes.
And that needs to somehow be reflected in those test reports, because you're going to run XFS tests and they will fail. And there is an agreement in the community that that failure is okay. But it's not clear to anyone else. And then you need tools to kind of support that kind of process and communication on, okay, this is still fine and that's not.
Oh, time's up.
Okay, thanks, Gab.
Yeah, sorry, I need to,
Okay, so I think we touched, I think, on a number of interesting questions. So yeah, we can either use this chat or someone suggests if there's some topic of more interest to just meet in a hack room again later this day.
And my mouse battery probably just died, so I can't even unmute or anything.
Gab, it's all yours. Thanks.
Right. Yeah. Thank you. Thank you very much, Lucas. It was really interesting, and let's see how it evolves. So now we are switching to another topic, and we'll have Priyanka and Bruce that will tell us about possible contributions of C groups and namespaces in freedom from interference. So now I'm going to hide myself. Actually, I've made Priyanka a presenter. I don't know.
Can you queue up her presentation before you make her the presenter?
Okay, maybe I will. Okay, so I'll take the presenter then.
Yeah, we were wondering about how that works.
Yeah,
so you might. Yeah,
I think Stu was able to. There we go.
Okay, now it should be okay. So yeah, Priyanka, you're presenter again. So yeah, it's all yours.
Yeah. So thank you everyone for joining. Today, me and Bruce are going to talk about kernel C groups and namespaces, and can they contribute to freedom from interference claims? So on our agenda, we have today is why freedom from interference is important in modern functional safe systems, C groups and namespaces overview, and contributions to FFI claim. So firstly, what is freedom from interference? Freedom from interference is the absence of cascading failures between two or more elements that could lead to the violation of a safety requirement. So here are two elements, element A and B. There is a root cause which causes a failure, a fault in element A, resulting in a failure A. And then that failure A becomes the cause of the fault number 2, which further results in failure B. So basically, there should be their shared resources should be used in such a way that freedom from interference of different elements is ensured. An automotive system consists of multiple software components that interact with each other. The presence of cascading failure from a non-ASIL or a lower ASIL component to a higher ASIL component will lead to one or many safety goal violations. So, for example, if there is an ASIL B communication module and that communication module might feed some data into cruise control, which is ASIL D. So that module can, it feeds the communication module feeds the data into cruise control module so that it can make right decisions in terms of braking and speed control. An instance where the communication module develops some kind of glitch and is not able to feed the right kind of data, it can be catastrophic. But here we, rather than assigning a higher ASIL level to such component, because it increases the cost by the significant amount. So in such kind of cases, freedom from interference and safety analysis methods like dependent failure analysis or FMEA can prove to be very effective. Dependent failure analysis not only validates freedom from interference, but as well as independence by identifying cascading failures and as well as common cause failures. So it focuses on single cause or events that could invalidate independence and freedom from interference. So here we see modern automotive systems adopt powerful SoCs that are capable of running diverse workloads concurrently. So here we assume there is a ASIL B compliant hardware on top of which we have ASIL B compliant Linux kernel. And here we have two different ASIL level applications. One is QM and another is ASIL B application. And let's assume that these are in container. This is in one container, the QM one, and ASIL B is in another container. So QM here is the quality management. So why QM here is when the parameters such as severity, exposure, and controllability are at their lowest, safety criticality calls for a QM level, which means the component here is not hazardous and does not emphasize any safety requirements. And the development supported by quality management is sufficient for it. The examples for QM could be gaming, radio, door panel local light, and in case of ASIL B, it can be the headlights of the car or IPC instrument panel cluster. So we intend to have freedom from interference between these two applications here. So from here, Bruce will discuss with us how C groups and namespaces contribute to FFI claim and what are the interference types where these features are more effective. So I hand it over to you, Bruce, now.
Thank you, Priyanka. I'll need you to flip slides. I'll just say when to flip them. Thank you. Please go ahead and flip to the next one. Thanks. My name is Bruce, and I'm testing Linux technologies for potential application in an automotive environment. At times, I'm going to channel the mind of a type of developer that I'll call the OEM dev. That's someone in an automotive manufacturer or a further upstream tier supplier to them. This person is a consumer of Linux technology, and they're going to come from a mindset of widely varying experiences regarding container technology, especially. Classically, they're embedded devs. They've got a little microcontroller. There are a dozen of them in the car. They think in terms of real time at times. And some of them actually have pretty strong experience with containers, which are more classically thought of as a kind of a cloudy thing to a lot of them. So you've heard a bit from Priyanka about the automotive space. And so I'll talk a bit about what Linux can do to serve up things to help it out, and then perhaps tie the room together. So first thing I'm going to say is I'm not going to define what a container is. I think in terms of tasks and processes, and there are many, many controls at hand. And I'm also not going to go into container runtime opinions because that's really policy versus mechanism. And I'm here to talk about mechanisms. So hang in there with me for a few slides. I'm not going to deeply recap these technologies, but I'm going to touch on them, touch the landscape briefly to catalyze the discussion. So containers basically primarily lean on C groups and namespaces. And these are mechanisms that control views and limit resources and help ease contention and basically sandbox things. Flip the slide, please. So here we are in 2021 with C groups, and C groups have become exciting enough to merit a second version of C groups. And container designers for the various engines are using many of these controllers now in various ways, whether they're one or two. C groups V2 is bringing rootless containers to us, and the take-up, again, varies among the different container runtime projects. And so C groups are QoS-like things. You've got I/O buckets. You account for who's using CPU memory. There's huge pages. There are several controllers, actually. And so that's one piece of the puzzle that I'm going to, as an OEM dev, try to apply to the situation. Flip the slides, please. Another major one is namespaces. And so these are kind of virtualization-like things. They provide isolation and sort of a view of the world to the container, and certain things exposed within the container are exclusive to it. There are several namespaces. Each of these are orthogonal and applied at various sets by the different container engines. And so we can make it look like it has a different host name, a different PID. We can pretend we're PID-O. We can have mount points to look like file systems. We can do network namespacing, which is very extensively used in telco, and also clustered, cloudy, SDN-based container management systems. We can have user group IDs. We can namespace IPC, and C groups itself can be namespaced as a protective mechanism from leakage to an unprivileged container. So flip the slide, please. So we've got these two technologies, and I want to think about them. And so the ISO specification says that the propagation can be considered. The propagation of failure. So that's the way Priyanka described it, where there's a potential fault in a lower level system, or in any system really. Can it connect to one that I hold to be important and in need of safety? And that sounds a little bit legalistic. So in order to apply that, if I'm the OEM developer, I want to understand the elements at hand and their interactions. And from that, I can perform an analysis, do some testing, and then hopefully make a safety assertion regarding suitability for use at the certain chosen safety level. When I'm engineering these things, nothing's off the table. And so although I mentioned C groups and namespaces, and that's hopefully what we'll kick around in a minute, everything else is available. So sorry, this is an older version of this slides, and I'm kind of working. There's slight. I'm going to make a couple of corrections on the fly. So the systems like Linux caps, seccomp, the parts that do. Let me cheat here for a second. Sorry. The Linux security modules. These are all available and at hand. And so on the slide, it mentions MLS. I wanted to say MCS. And so I was actually going to get a little bit into, suppose I tried to craft a solution and I could use a runtime that combines seccomp, MCS. I would consider MLS, but I would say maybe that's not going to map into different safety levels. I'll just stick to the MCS side of SE Linux. Now, in my corrected slide, I mentioned AppArmor. I'll give a shout out to them. And there are other mechanisms. And so I'm going to flip the slide. And so during the analysis of all of those available technologies and choosing a runtime, I'll connect these against the interference types, and having a way to sort of classify these interference types aids in the understanding and the reasoning. And so I can then decide if I need additional technologies and perhaps ask you all for something that I may not see there. So this is the last slide, and I've classified 3 types of interference, and this is something that Gabriella does very well, in fact. Time interference is a bit like, hang on a check, I'm going to cheat again. It's the things that cause delay. Spatial interference means literally separation of memory spaces, registers, caches, and it can be described, problems can be described as scribbling in each other's spaces. And then for communication interference, that can be termed as jamming or signal to noise. Can something make so much noise that it actually denies stuff from other subsystems? And so we're now at the point where I'm about ready to let folks jump in and start talking about what they might think is there missing. For the time interference side, I would be thinking of CPU exhaustion, which seems to be controlled by C groups. Latency is covered by niceness, and for example, I'd ask, do people think they need something similar in C groups to deal with latency activities as opposed to just percentage of CPU? The flow control monitor bit, that's something Gabrielle had, and I'll let him mention it if he wants. And then for spatial interference, we can pin CPUs, set memory limits, IO buckets, and even hide devs. And for communication interference, it's actually possible to turn off networking. And this gets a little bit into how containers so far have been very network centric. The opinions of the container runtimes basically say a default container is fired up and it can pretty much open a real network socket. And that's supposed to be your use case. But as an embedded practitioner, I would say, well, I want to do some IPC, shared MEMS, some SEMS, and a few other things. And so I might manually pull elements in. And so I'm now going to tie it up and say that I haven't seen something leap out as a scary missing thing. And I'm going to let it go to the group. I tried to pull up the chat, but it's not loading in my browser. So I'm going to let Shah or...
Would you like me to read questions for you? Yeah,
I would love for you to read questions, yes. Thank you.
Priyanka, can you see the chat?
Yes, I can see the chat.
Oh, here we go.
It seems, I mean, the chat is about the box. I think the previous, no, there are some.
Gab, do you have, are you?
Yeah, I'm looking at Carlos O'Donnell. I mean, this is the one. So at the hardware level, do I have any way to control non-temporal store bandwidth sharing between containers?
Controlling bandwidth between containers, is that what that is?
Bruce, I can give a bit of context there. Yeah, so I'll give you an example. At the hardware level, at one point, between Intel, Oracle, and Red Hat, we were looking at a problem that had to do with multiple processes and how much cache line utilization they're given. Because when you do a store, let's say on an x86, there is a finite amount of, let's say, non-temporal store bandwidth. And so depending on how you configure your individual processes, you can actually have one process starve a box at the hardware level for non-temporal store bandwidth and affect the performance of everything else on the platform. So I don't know that there are great ways to mitigate this, but it definitely falls into time interference because the memory controller and the CPU at the bottom level of the stack have some interaction there. So it was just an open question for me when I see this slide.
That's interesting. Can I summarize that to say it's like right back thrashing? Is that a good way to recap that?
It is, yeah, you could recap it as that. I mean, there are ways. I know that Intel has and I'm going to blank on this. They've got a hardware controller for like actual page cache allocation. Is it CAT or something? I think it's called CAT at the low level. And I've never seen CAT configured in a way that prevents this kind of stuff. So that's it.
That's interesting because this kind of helps touch on how some of the control elements sort of smear across. So for example, CPU pinning can help with cache exposure vulnerability problems. However, there is the potential for immediacy of access based on the pinning, and depending, I mean, there's so many ways that caches are structured. So I'm kind of stretching that a little bit, but it gives a sense that some of these kind of spread across, time or spatial or communicative. And so it's an interesting thing you bring up, and nothing leaps out to me, but I would say that whenever I hear something like this from engineers, I would try to craft a test for them. I'm on the QE side, and so I would want to say, let me fire up some containers and write a little bit of code that does those probably some deep level memory access. I'd have to probably size it up pretty well, maybe even look at the particular architecture. The OEM developer, they will have picked a certain architecture, and they will look deeply at the hardware, because the person that hands over the keys to the car, that OEM is the one that makes the final assertion about a safety claim. So they're going to look at the hardware manual for that particular SoC, and nothing's off the table. Yeah, thanks for that. What's up next? Somebody shout whatever's being typed or whatever's next, and then at the end I've got a couple of little questions I'll throw out as sort of box starters. Anything?
So Bruce, I had one question, and the question is really around the fact that you talked about spatial interference, and you also talked about how we need to isolate resources like CPU resources. And today, as far as I know, there doesn't exist any way to isolate the CPU resource itself. From a point of view, yes, you can use a C group CPU set, and you can pin CPUs for a container, but each container still gets the entire view of the system essentially, and they are not really isolated in that sense. So what do you mean by spatial interference in this context?
So spatial interference is all physical separation, so that includes memory spaces especially, and it kind of touches into one of my questions later. So what I like about your question is it calls into question, C groups allows pinning, but it still allows certain things to be exposed, and is that insufficient for the matter at hand? And personally, I'd have to look into it we have security people who would reach to and say, hey, I've pinned the CPUs, I have exposure. What do you think about that? And this gets into a lot of back and forth about how much control is available versus what's in use. And so I'm not going to say it is or is not, but I think it's great. These kinds of questions are the sorts of things that are good to bring up.
Yeah, I asked this question because I was recently working on a prototype for a CPU namespace mechanism, and I thought that your use case for removing interference it would be ideal for what we're doing. So that's why I wondered that if there are use cases around this, and if there is really a need for it, then I could push forward for something like this.
I'd love to, yeah, I'd love to continue a dialogue and maybe establish, especially just kind of kernel wide, not just in my place where I hang my hat. That sounds cool. It's fun to kick new ideas around. Definitely. Thank you.
Sure.
I have a question, Pratik. Did you, I mean, from my understanding, so C groups allow to specify a CPU set to be used by a certain group of processes, for example, right? So, and that would basically, it would make practically impossible for this process to run on other cores, right? Or
this process to run on other cores. Yes, you're right.
yes. So then my question is, what would be, so where do you see an advantage of actually making the CPUs invisible, if anyway they cannot be, used by the process? So.
Right. So I can think of a couple of reasons. One of them is that, say, if you want to pin to say just 4 CPUs, but your system has, let's say, 1,000 CPUs, but when you've pinned to 4 CPUs, and this information is in the C group mechanism, and as we know that C group is a control mechanism and not a display mechanism. So your application is most likely to look at an interface like sysfs or procfs to get its information about how many threads to spawn or how many resources to allocate, and there it's probably going to spawn you 1,000 threads, and even when you are just really capped on 4 CPUs. So that's I believe that's going to hurt your performance. That's one thing. Another thing I could think of is potential fair use implications, right? Maybe on a multi-tenant system, you could be like, if you know the whole topology of the system, if you know which CPUs on which node, and you could possibly even cause a denial of service attack in a way. Or if you know where the GPUs are, which bus is closer to where, you could probably get an undue latency advantage if you when you're accessing when you have a workload designed that way. So that is something that I'm thinking of. Yeah, it brings it slightly more closer to a virtual machine, but not quite. And it does. I believe it. It would probably give that performance boost that a virtual machine or even a Kata container. Let's face it, that's a virtual machine as well. That would also incur a performance loss or a performance penalty that just having a namespace you wouldn't incur with.
Okay. That's interesting. I'll make an elaboration just so somebody can clarify me, and this doesn't undermine any of your ideas, but it's my understanding that CPU set is a union of the granted and pinned CPUs, and so there's some that they can't even see, but I might be wrong. So if somebody knows I'm wrong, let me know. I'll also make a more general comment about your line of thinking, Pratik. The idea as these folks attempt to the automakers are tempted to collapse more and more stuff into these nice, powerful SoCs that have GPUs, and there's a temptation to, on one system, do the body control module, detect pedestrians, and then do telematics. And so what's trying to be protected against is the notion that you're going to get in your car one day and you're going to try to turn it on, and a QR code is going to pop up on the IVI that says, you need to scan this with your phone to send us some Bitcoin, and we'll let you have your car back. That would suck. That would be a very newsworthy situation for those poor folks. So these things about everything's on the table as far as crazy scenario. No scenario is crazy. I'll say that. So thank you. Anything else before I throw out a couple of questions? Please jump in. Please feel very welcome to jump in.
Go ahead, Bruce.
Okay.
Go ahead, Bruce. Yeah, go
All
ahead.
right.
Your questions.
So I'm gonna have this sort of prompting questions, and someone can jump in if they think they've got a response. Do we have enough namespaces? Are there ever enough namespaces? Will it ever stop? Do we have enough C group controllers? I won't get too much into the way the hierarchies and the lead versus node system has changed. That's sort of a schematic choice versus a capability choice. But there's a wide set of controllers now. If people know of things on the horizon, more things than what we just heard about, love somebody to jump in and say, I was thinking about doing this namespace stunt or a new controller of some type, or I had this use case in a different endeavor. Do you think it would apply to auto? The way the controllers negotiate with the subsystems isn't good. So this gets into granularity. For example, on the memory side, it's pretty much a per page granularity, even though the files are specified in bytes. That sort of makes it easy to the user. So I, as a very high level consumer of this, would say, okay, is page granularity good enough for me? Does the system, is it every page allocation? It kind of looks that way now. Somebody can correct me if that's not the case. Other elements are sort of buckety, where they're periodically measured at around, I want to say, a microsecond level. So if anyone thinks they've experienced problems with the granularity of controllers catching up, that would be interesting to hear about. Jump in. C groups v2 is not controlling real-time processes. And so all of them must be in the root C group for a CPU controller to be enabled against them. Has anyone found any insufficiency with that so far, or had any thoughts, or does somebody want to shout about work that they're doing on and when that might happen? Okay. Does anyone think that the presence of hypervisory elements, and specifically I mean KVM because this is Linux Plumbers, any of those elements that would cause a contention problem? Is there something that collectively I call all these things control surfaces? So the C groups, namespaces, security mechanisms, seccomp, blockage of syscalls, everything. I just call them all control surfaces. And so when I think about hypervisors, has anyone had any scary thoughts about them? You can jump in. And my last thing, my last prompt I'll throw out is whether virtualized GPU functions would be sufficiently under control. It's very, very easy to imagine that a GPU in a vehicle is segmented where some part of it is trying to detect a pedestrian and the other part is trying to play a SpongeBob video in the backseat for the kids. So there's a temptation to use virtual GPU segmentation with C groups, etc. The way they're exposed as devs sufficiently deal with that story, or at least prompt thought as you all work on newer stuff for the kernel. That's all I got. I'm going to throw it out to the group for any other chat or how are we on time? All right, we're down to a minute. That worked out kind of well. I'll throw it to Gabe for just a second when he talks about external flow monitor, because that makes me think about safety chaperone processes, but Gabe might be thinking of something different there.
No, yeah, well, now the time is up. So the idea is like, do we need to rely on a container if we have an external watchdog that we regularly pet, right? Because if there is any time interference anyway, it is detected by the watchdog, right? So, but And I guess the answer is yeah. Anyway, we need to rely on containers at least for the availability of the system. If you don't want to see a very hungry customer. Okay.
And thanks so much, everybody, for hearing what it's like to be to channel an automotive developer. I'm grateful for everyone lending their time.
So Shua, I will hand over to you because I need to basically go to. I need to return to the other conference. Okay.
Yes, thank you, Gab. Hand it off to Brendan. He's controlling the slides for us.
Thank you very much, guys.
Thank you. Okay, Brendan and I are tag teaming for this presentation to talk about kernel testing frameworks. Quick overview. We're not going to talk too much about it. And we also wanted to talk a bit about code coverage. Rachel touched on that earlier too, so it'll be a complementary presentation in terms of our content. It works well together. Let's see. I'm going to quickly say why K-self-test, right? K-self-test is the regression test suite that we have in the kernel. It focuses on testing the kernel from user space. So we have shell scripts, C programs, and some of the shell scripts use kernel test module as needed to exercise some of the kernel code paths. And this shell script, this test suite, breadth and depth coverage. So you might have, a subsystem might have several tests and subtests underneath. And then also we have several subsystem tests. It is not for workload or application testing, for sure. And let's see more on this. It's feature functional and regression testing, and perfect for bug fix focused regression testing. When you find a bug, when it's fixed, you could add a regression for that bug. Subsystems testing as well. So a lot of maintainers and developers, when they find a bug and they fix it, they do add, in some cases, a regression test for that. It's perfect for user APIs, system calls, critical user paths, and common use cases. So it is perfect for end-to-end regression testing, and it kind of gives a feel for, well, hey, everything is working. At least some of the critical error paths we are testing, and any of the success paths we are testing. And I consider this a combination of open and closed box testing. And you can take a look at, for more information, you can take a look at this detailed information. There is a webinar that I did a few months ago. You can check that out. Why KUnit? I'm going to talk about what Brendan is maintaining for. It's kind of so the KUnit focuses on in-kernel testing. It's perfect for testing internal kernel APIs, libraries, drivers, individual units of code, and perfect also for being able to test edge cases. And it kind of goes down deeper into some of the edge cases, and you can exercise the cases, some of the kernel code paths that you cannot reach from user space. There's quite a few of them. So it makes it easier for leaf nodes and error paths to be tested, and you will be able to go down into those, which is not possible if when you are doing it from the user space. User space has, unless you are continuously writing test modules, right, in terms of kernel shell scripts and invoking kernel test modules. So a little bit, let's touch on a little bit on McCabe's complexity, which is also known as cyclomatic complexity. What it is really is that it is, if you look at the upside down tree, right, and you are calling making a system call, so even a system call such as a read call, for example, it could go down into, propagates through several kernel subsystems, block layer, file system, and all of that, and it's really expands into a upside down tree with ever expanding branches. So how do we reach all of these edge cases? Imagine trying to reach arbitrary edge case, for example, that read could go down on. So kernel self-test, for example, will be able to test some of the success paths, but what about the failure cases? What about all the different call paths, code paths it can go down on? So that is the complexity, and how do we test those? That is one of the complexities. And I do think that KUnit is a practical way to be able to go down different paths, and you can go majority of the edge cases. Nothing can probably test all of the edge cases, right? So, and successfully, if you were to test a read, say I'm going to use read system call from the user space, very often you can test the success path very clearly, but not the all of the failure cases. So at this point, I'm going to give the talking stick to Brendan so he can speak to the next few slides.
Awesome. Thanks, Shua. It looks like you have control over the presentation, so you wouldn't mind switching to the next slide. All right, so some of what, like Shua mentioned, Rachel already covered a lot of stuff about coverage, so some of what I mentioned, I'm going to try to avoid repeating points. But nevertheless, Rachel already gave a pretty good description of what GCov is, but I don't think she showed any examples of what the GCov report looks like for an individual file. So if you look here, the blue line, this is an example that I snipped from a file that had GCov coverage run on it. And you can see blue lines are lines that were executed, red lines are lines that were not executed. And white lines are lines that there's basically no real execution, like declaring a variable, there isn't any, anything to actually do there. In some cases, one line split across multiple lines. So I'll get a more concrete example of this later. Next slide, please. All right, so Rachel did mention this, so I'm just going to briefly remind everyone. Next slide. So this is where you see, so this is basically like this whole page is basically the coverage for a directory in the kernel, and down here are coverage for individual files and subdirectories. And then next slide. And then here is the coverage for the entire directory, and if you're at the root level, then this would be the coverage for the entire kernel. Next slide. Oh, I think the slides that I skipped when we were putting this together, Shua, were ended up being uploaded as part of the PDF. So I think there might be a couple slides to skip here. You can skip this one. Yeah, you can skip this one. You can skip this one. Okay, there we go. And it looks like it readjusts my arrows. But anyway, so here's an example of, I actually pulled this out of an actual KUnit test. So there's a test case that covers this particular function, dev PM QoS add request. It's actually wrapped in another function, but it's basically just handling locking and stuff. So I'm showing the interesting one. So this function's already covered by a KUnit test, but you can see these edge cases here. The dev PM QoS min frequency and max frequency are not covered by that test case. So because we already have a test case that covers this function, trying to cover these lines would be pretty trivial. All you'd have to do is basically copy the setup logic in those test cases and then create another test case which goes over these edge cases. And really all this boils down to is just a different input type into this function. So the fact that you're able to call this function directly from KUnit using in-kernel APIs and combining that with coverage reports is really, really powerful. Next slide. All right, so please don't construe anything that I'm about to say as like a counter to anything that Rachel said in her talk or anything that was a counter to anything that was in that discussion earlier today. I put this talk together before that discussion, so I didn't even know there was going to be another talk on coverage. So I talked a little bit about what coverage is. So I want to share some of my thoughts on what coverage is not. Coverage is not a panacea. It is a very, very powerful tool, and it's extremely useful, and I would strongly encourage people to use it more. I think, kind of like what I was saying earlier today, I think it would be great if we could make it available for on every patch set. If we could link a coverage report, that would be awesome. But it also doesn't automatically fix your testing problems. Like it doesn't even tell you whether your testing is good or bad. Like, yeah, if you drill down into an individual report, it's going to give you a very strong sense of whether you've covered everything in your testing. But even if you have a really high coverage number, it doesn't necessarily show all of the combinations to how you got to those leaf nodes that Shua mentioned. So and the flip side of it is there are things for which providing coverage for is not necessarily useful. Like I mentioned, I don't know how common this example would be in the kernel, but I worked on a team at one point that was able to achieve in this one code base ridiculously high coverage. Like it was almost 100%, but they had tests that tested like generated code that was like generated by like this thing that generated like REST API like code, and it was like they weren't useful things because like the people we used that code generation for had already like super well tested their code, so it was just testing a particular instance of like the code that they generated. So my point here is I don't think that there's a right coverage number. I think that it can be useful to give you an idea of what the relative coverage is, and maybe this deserves a little bit more attention. But I don't think that looking at a coverage number is going to automatically tell you one way or another that the coverage here is good. Next slide, please. And the other thing is there's a lot of different ways to measure coverage. Like GCov immediately shows you that there's line coverage, there's function coverage. I don't know if they show branch coverage, but those are all different useful things to look at. But another thing that I'd like to bring to people's attention is the distinction between absolute coverage and incremental. Next slide. So absolute coverage, I think up till now is mostly about what we've discussing. It's pretty much what you expect. It's just the coverage of any given set of tests across the entire code base at a given point in time. Incremental coverage, I think, is something that I've not seen talked about much in the Linux kernel community, but I find it to be, especially when you're trying to establish that initial test coverage, it can be a lot more useful. It focuses our kernel patch as opposed to the entire code base. Next slide, please. So because of that, because you're only showing the coverage on changed lines, that has incremental coverage and absolute coverage are different things, but I think where we're at right now, that has some certain benefits. Incremental coverage, first off, it's a lot easier to achieve a respectable level of coverage earlier on when you have a code base with relatively low coverage. And don't get me wrong, like until you kind of have some test cases some tests to build off of, and it's a lot easier to test a subsystem when there's already some things in that subsystem which are tested. And you're working from zero, it's always going to be hard. But once you've kind of established a sort of baseline, even if it's very, very low, it becomes much easier to achieve a high incremental coverage, because you only need in order to get high incremental coverage, you only need to cover the code that's actually changing. And that helps prioritize code which is likely to be buggy. Like, bugs are going to be introduced by new changes. There may be bugs that already exist, but those are more likely to get shaken out over time. So you really want to focus on the new code. And also, in addition to that, incremental coverage is usually more actionable by developers, because the developer can, you can't really, of course, there's always going to be people who like, oh, there's a problem here, I need to change some part of the kernel. But it's a lot easier to motivate somebody to change something when you can point out something wrong in their change. And incremental coverage makes that easier because you're only focused on what they're changing. Next slide, please. Now, I'm not saying that absolute coverage is not important. Like, I think it is a true statement to say that old code is less likely to contain bugs, but I think it's also a true statement to say that the bugs that it contains are often probably worse. If they've been around a long time, they're at a greater risk of being a security concern. And it's also going, in some cases, that unintended behavior can become somewhat intended behavior. And I'm sure everyone here has who's has a lot of experience developing code will probably have some interesting stories about code that had kind of intended, weirdly unintended behavior. And of course, it's also way easier to compute, and it's also really useful for comparing the health of subsystems. Next slide, please. I think this is my last slide.
Oh, I think, okay. I was going to cover this one. So thank you, Brennan. So K-self-test, both of these have their advantages. Talking to Brennan's point about code coverage, I think you could combine the two to be able to achieve whatever the code coverage we can achieve. If you are doing a depth test in covering deeper code paths, you can do that with K-self-test to some extent. It is any of these test frameworks really are as good as the test itself. The test plan, the test needs to be, whoever is writing the test have to think about the paths they are going to test. It's like a musical instrument. It's only as good as the person playing it. So these frameworks are in place to be able to give you the, like for example, easier faster to zeroing in on a kernel specific area using KUnit. And you could exercise several flags in a system call using K-self-test. But all of this is, it just depends on how good the test is. So now I want to also, there is 2 webinars. Brendan did a webinar a while back, and I did a webinar on K-self-test. Please check those out. They're on on the earlier slide, slide 7 has a link to KUnit webinar. All right, so I want to open it up. We want to open it up for questions now to say code coverage important for safety. What is the importance? And then also, what is a good number for code coverage? And what kind of improvements can we make to the framework itself? And then also, like I said, tests are more important. Framework is there for tests to be written, and more tests for regression, more tests for coverage, and anything else. Questions, comments? Yes, David is talking about a testing overview page in the kernel docs, which covers the differences between KUnit and K-self-tests and when to use what.
Oh, that's a really good point by Moto. Yeah.
Yep.
Yeah. Developers should own tests, not like test engineers. I mean, test engineers are, good and valuable, can help inform like good tests and testing procedure, but good testing is also informed by developers.
So that is one of the reasons we are keeping K-self-test and KUnit in the kernel, so that developers can write tests when they make a kernel change, and also when they write a new API, new feature, and so on. So that is one of the big reasons why we are keeping these in the kernel tree.
That's a really good point. I actually came from the background of I started working on KUnit when I was working on a driver. Actually, it was a couple drivers, but I was working on a driver, and I just found it really frustrating to like why are all the tests separate? When it came to testing particular like error paths and stuff, it was just like it was very, very difficult to do, and it was something that was pretty easy to do in other code bases that had some things like KUnit and stuff. So yeah, having the tests live with the code is I think that there's a lot of test code bases out there for the kernel which are obviously really good, but I think having options for developers to be able to have tests live with their code is critical.
So Rachel, yes, you have a good point that writing tests should be shared. And it is, that's how it is, right? The kernel developers will write a test, and that is, anybody can go and update the test and make it better. So we always welcome patches that make our tests better. So I do know that I do say this, that as a developer, and I also write tests. I have done it forever during my career. Sometimes it's like you cannot find the mistakes. You cannot be editor of your own blog or something. So that's where Rachel's point comes in, that test. That's where the closed and open box testing comes in, of course.
Published code coverage results for KUnit. I don't think we've published them. I mean, hypothetically, okay. I do have. I could try to find something because I actually have a coverage report open on my computer somewhere that has.
I think there are some really old ones somewhere published, but
yeah, I think you're right, David. But let me see if I can. I'm not sure what the easiest way to share this is, because it's actually like on this coverage report's like on my personal machine. I guess I could probably just share a picture of it, or I could just tell you what it is and you could take my word for it.
We could give you a presenter and you can share your screen if you want.
Oh, yeah, I could do that. Yeah, I'll do that.
You're a presenter now.
Okay. All right, so here's the coverage report I generated just the other day. If you look at libs.kunit, we're at 75.8% coverage by line coverage, and by function, we're 77.4. That's where most of the logic lives. But we do have some stuff in include/kunit, and apparently that's 100%. So, oh wait, no, sorry, we're 87%. Okay, I was looking at lib/math. So, I don't know. Is that, we try to practice what we preach. Try to. Yeah, I guess these are going to be uploaded as videos, so I guess we've published it now, but we should probably do a better job of like actually publishing the data over time. We have a presentation yesterday. I showed some graphs of KNIT's growth, and that's based on a spreadsheet that we've been using for tracking KNIT growth internally. We were planning on uploading that spreadsheet to the knit.dev website, and one of the columns there is the coverage per release, but we only have it for the last 2 releases for reasons.
Obviously, also, if you're looking for like coverage over the whole kernel, that's not really a perfectly well-defined thing, because you can't run all of the KUnit tests on any given kernel, because some of them are testing features that are actively in conflict with each other.
Yeah.
So you get coverage results for a given configuration. And I think these ones would be presumably just the default UML configuration, but
so AJT or AJD asked how many tests a KNIT tests are in the tree right now. There are about 300. So in 5.14, I believe there was 297, 298, somewhere around there. And in 5.15 RC2, I believe there was 308. I remember correctly.
it's 281 for 5.14 and 309 for RC2 of 5.15.
Okay.
And that's the number of test cases, not suites or files, but individual test cases.
Yeah.
So I have a question. So when you're talking about, David, you're talking about UML. What level of confidence can somebody in a ARM architecture, per se x86, have when they run these tests on UML?
I'm sorry, I don't think I understand the question.
So the level of confidence of running these tests, obviously generic code, you're good with that. But what would running all these tests on UML give the same level of confidence to a maintainer or a developer that's working on a specific architecture?
I think you can go ahead,
Yeah,
David.
it depends a little bit on what you're trying to test. If you're trying to test architecture specific stuff, you're always going to be more confident it's going to work on that architecture if you've tested it on that architecture. And that's why it is possible to run KUnit tests on whatever architecture you like. If you're testing some totally generic function that you don't think has much architecture specific stuff in it, the difference between testing it on UML, where it's going to run really quickly, and testing it, on any given architecture, the trade-off there may be a lot better. Yeah, just run it on UML. It's a lot quicker. A test that runs quickly enough that you run it is better than a test that runs slowly enough that you don't run it at all. But
Right.
You can run the tests on any architecture.
Right.
Yeah.
So,
Go ahead.
Sir, Mark has a question. Has there been much activity on moving KSL Plus to KTAP output? I recently converted some myself. Not that I know of. I keep doing that when I get time, as time permits, but I haven't. Not that I know of, Mark. Go ahead, Brendan.
I was gonna say something else, but yeah, I think we had an intern, Ray, who submitted finally formalizing some of the KTAP stuff. So I think what the follow-up revision that she wrote, which we haven't posted to the list yet, unfortunately, but it looks a lot more like what K-Self-Test is already doing. So I think K-Self-Test is probably like mostly there. Most of the tests we looked at anyway. But of course, it's people need to actually agree on what's going to be in the KTAP spec. So, but yeah, I think that we're pretty close to having that done. So,
our time is up, Brennan.
Yeah.
Okay. Thank you, Brennan. Thanks, everybody.
Thank you. Oops.
Just trying to find my last slide. Okay, so thanks everybody for joining. And this, I can't control the slides, looks like. So I wanted to.
Should be able to now.
Okay. Wanted to leave you with that we have continuing this conversation in the upcoming ELISA workshop. And I will put the link in the chat here, and then please join us for that workshop as well. It's upcoming in November. Thank you. Kate, do you want to say anything?
No, I was just trying to find the slide you were looking for.
Yeah, I thought I uploaded it to BBB. I can't find it myself.
Okay.
So that, yeah, I uploaded all of
chat,
this. Right. Okay.
All good.
Bruce, do you have a question?
Yeah, as soon as I figure out how to unmute. Sorry. I see there's a recording. Are you guys going to make that available or chop it up into the pieces? Also wanted to send lots of thanks for setting this up. Thank you.
Kate, are you going to answer that?
Since it's a mini conf, I figured you might know more than me. But
Yes. So, no, basically, it's already being recorded. So right now, the live one big blob is available. But your next question is it going to be broken up? I believe that's why we hired the E3 team. Then there should be. That's why if you notice one of the E3 webcasting is watching this because they're recording this, and it should be all broken up by. So you can jump right to the topics. I believe that's what we're doing.
That's what my understanding too.
So yes, it will be available.
We don't have timelines quite yet for that.
Yeah, it'd be really great to pick up on the sessions that I missed. There was lots of interesting stuff. Thank you.
And if you go to watch live on, if you go to lakesplumbers.conf.org and go find the watch live that has all these being live streamed right now, the ones that were live streamed yesterday and this one probably in a few hours will be available to watch. It's just that it's going to be a lot. You have to kind of fast forward to find the location. I've already looked at a few, watched a few from past days.
Thanks.
Okay, I did find the slide. So here is the upcoming Alyssa workshop running from November 8th to 10th. Submit talks. We can continue the conversation, some of the code coverage and other things we have discussed today. Thank you.
Thanks, Shuas. Thanks, Kate.
Sure thing.
One last thing. Did you make sure you saved the notes?
No, not yet. Thanks for the.
So yes, click on that those two little arrows above the shared notes.
Okay.
And it'll let you share in several formats.
I'm trying to find it.
So if you click on share notes.
Oh, yeah. Yes, got it.
This is import, export, export as PDF, plain text, Microsoft Word.
I just learned that then. I've been scraping manually. Well done. Thanks, Steve.
Okay. Is there a way to record, save the chat, Steve?
Yes, I could get it for you.
Okay, thank you. Sometimes there is a lot of good information there. It would be useful to have that.
Let me go. I'll try to get that to you right now, and I'll probably email it to you.
Okay, great, awesome. I think I saved Etherpad, HTML, plain text, so I'm good. Thank you.
Yep, I usually do HTML, plain text, and PDF for the heck of it. I don't know why, but.
Okay.
Thanks, guys.
Okay.
Thank you. All
Bye.
right. Bye.
And
Go
Kate,
ahead,
I'll let
Steve.
you when you're. I'm about to say, Kate, I'll let you close it up when you feel like you want to wait a little bit longer, and then close up the shop, or I could come by, close up all the rooms.
I don't think anyone's talking right now, so I think you may as well just close it off at this point, since we've all saved the shared notes, and if we've got the chat, the discussion may continue in the chat too. I think we've just got the people who've got their stuff sitting there and walked away at this point. So, yes, I am a presenter. Okay, fine, I'll close it. Unless you want me to do anything else, Shua. No, she's gone too. Okay.